Hello students. So here we are after taking small baby steps with ratios, proportions, indices, logarithms, with equations in our lives, left hand side equal to right hand side. Then came inequalities. Not everything was going great in our life then, but then we got money. We learned the value of money and time value of money. We tried different permutations, combinations. We saw the sequence in our life in AP and GP. We put different things in our life in different sets. We understood the relations and we understood how we function. Here we are now at the last stage where we see what has happened so far and how things would have been different. A small change would have led to a bigger change in life. One decision would have changed everything. So we now enter the world of calculus. Now in calculus, we have two parts. One is differentiation calculus, one more is integral calculus. I will teach you from the point of view of examination. I'll not go that much into detail, but how much ever is required from academic point of view, I'll definitely explain. So as you see on screen, we have calculus, two parts. One is differentiation, another one is integral calculus. Two sub-methods are there under both of them. We'll look into the detailed as we proceed. For now, we will start only with differentiation. What's integration? We'll see that later on. We'll keep that aside for the time being. In differentiation, what are we studying? What is differentiation? First, the meaning of differentiation. Differentiation is study of change. Let me write that. Study of change. In functions, also I was speaking something related to independent variable, dependent variable. Let's write down the standard form. Let's write y is equal to ax plus c. Correct? So here we have two variables. We have x, what am I highlighting now, and we have y. Correct? X can take any value. This is called independent variable. Independent variable. But y's value, as we say, y is a function of x. Y's values are dependent on the values of x. This is dependent variable. C is definitely constant. Correct? So small change in x can lead to change in y. How much it makes a difference is differentiation. So differentiation is, let me switch back to black. Okay, change in independent variable, dependent variable, change in dependent variable with a change in independent variable. Change in independent variable. Okay. Now, how do we write change usually? You must have come across this in economics also. How do we write change? Change is denoted by delta. So we have delta. Dependent variable. Which one is a dependent variable over here? Y, right? So we have delta y divided by delta x. Perfect. Delta. What is the first letter of the word delta? D. So we call this as d of y, delta of y with respect to delta of x. So that's how we get dy by dx. If you studied differentiation before, you would have known by now that we say differentiation is dy by dx. What it means is differentiation of y with respect to x. I'll write that as well. Differentiation of y with respect to x. Let me just repeat it. What is differentiation? Change in dependent divided by change in independent, dy by dx. That's it. Now let's see what are different things that we have in this particular topic. Okay, differentiation. Coming to the bird's eye view. First, we have standard rules and laws. See, maximum is covered over here only. Then we have some problems from implicit, a few problems in parametric functions and logarithmic differentiation, but the majority of the part comes in standard rules and laws itself. First one is standard rules and laws. We will start with that. Okay, as I have already given you, differentiation of y with respect to x. Differentiation of y with respect to x. I'll rewrite this dy by dx. Fine, because this is how we will be writing it later on. Differentiation of y with respect to x. Then you need to remember differentiation of x to the power n with respect to x. Differentiation of x to the power n with respect to x. What is that equal to? N into x to the power n minus 1. Fine. We will take one example. Okay. I will switch to a different color now. Let's take blue. Okay. If I have a question, okay, differentiation of, I need x, right? So we have x to the power 5. Let's take differentiation of x to the power 5. What is this equal to? Now, what does the formula say? N into x to the power n minus 1. What is n equal to? N is equal to 5. So we have 5 into x to the power 5 minus 1. 5 minus 1 is equal to 4. This is the answer. Simple? Yes. Okay, next we will take differentiation. Differentiation of just x. Differentiation of just x. Actually, this is not a separate formula. It is a continuation of the previous one only. Differentiation of x to the power n minus 1. Now, what is x? X is nothing but x to the power 1. So it becomes 1 into x to the power 1 minus. So it becomes 1 into x to the power 1 minus 1. 1 minus 1 is 0. So we have 1 into x to the power 0 is equal to 1. 1 into 1 is 1. Correct? It's just an extended version because I wanted to remember whenever there is x, we will be directly writing 1 instead of writing all of this. Fine. So differentiation of x is equal to 1. One more. Differentiation of 1 by x. Differentiation of 1 by x. Now this also actually is the extended version of x to the power n only, because it is x to the power minus 1. Correct? So this will be equal to differentiation of x to the power minus 1. Correct? Okay. Now what is the differentiation of x to the power minus 1? Minus 1 into x to the power minus 1 minus 1. And what will that be equal to? So we have minus 1 divided by x to the power minus 2, right? I mean into x to the power minus 2. So I'll take it to the denominator, x to the power 2. So minus 1 by x square. Minus 1 by x square. I'll just highlight what is important. Okay. Here this is required. N into x to the power n minus 1. Then here differentiation of x is equal to 1. And then we have differentiation of 1 by x is equal to minus 1 by x square. I hope you have no doubt up till here. Next we'll move on to the next formula, differentiation of e to the power x. Differentiation of e to the power x is equal to, very easy to remember, e to the power x only. Differentiation of e to the power x is e to the power x. Okay. Differentiation of next one, we have log x. Differentiation of log x is equal to 1 by x. 1 by x. Fine. These are all separate ones that you need to remember. When we have e to the power x here and we have 1 by x. Fine. I will be writing all of this again later on to put it in one place. Next we have differentiation of a to the power x. Last time it was x to the power n. Now we have a to the power x. Differentiation of this is a to the power x log a and base e. Remember in calculus when base is not mentioned, it is always base e. But remember in the earlier logarithm that we were studying, whenever base is not mentioned, we used to consider it as base 10. Okay, here it is base e. So differentiation of a to the power x is equal to a to the power x log a to the base e. Okay, for now for explaining this one, we will take one example. Differentiation of, we will take, give me a number, let's take 7 to the power x. What is this equal to? 7 to the power x log 7 to the base e. That's it. Fine. Next, differentiation of a constant, any constant for that matter. Differentiation of a constant, a fixed number. What is that equal to? 0. 0. Okay. Fine. Next, we have differentiation of root x. Differentiation of root x. Now, this also is in the form of x to the power n. How is that? X to the power 1 by 2, right? Now, this I can write it as differentiation of x to the power 1 by 2. So, it becomes 1 by 2 into x to the power 1 by 2 minus 1. And when we simplify, we get 1 by 2 root x. This is relevant to me, this is relevant, and this is relevant. Fine. So we have taken this standard rules that we have in differentiation. Fine. Let me just repeat it for you. First, we have x to the power n, that is equal to n into x to the power n minus 1. Then we have differentiation of x, which is equal to 1, differentiation of 1 by x minus 1 by x square, differentiation of e to the power x, differentiation of log x, 1 by x, differentiation of a to the power x is a to the power x, log a to the base e, differentiation of constant is 0, differentiation of root x is 1 by 2 root x. Just so that you get comfortable, now I'm rewriting all of this again in a separate paper. Okay, fine. This side we'll write the formula. We will divide this into two parts. Fine. Okay, we'll put everything at one place now. Fine. So we started with, on top I will write d by dx. Okay, differentiation with respect to x of, and this is the value. Fine, this is after differentiation. So differentiation of x to the power n is equal to n into x to the power n minus 1. Differentiation of x is equal to 1. Differentiation of 1 by x is equal to minus 1 by x square. This time I will take root x. Okay, differentiation of root x is equal to 1 by 2 root x. Differentiation of e to the power x is equal to e to the power x. Differentiation of a to the power x is equal to a to the power x log a to the base e. Then what else do we have? Differentiation of constant is equal to 0, and the last one, differentiation of log x is equal to 1 by x. Clear? This much, if you know, we can start solving some of the questions. Now we'll move to some of the laws of differentiation. Let me write that down. Laws of differentiation. Okay, laws of differentiation. The simple things only. First one that we have is constant rule. Let me write that down. Constant rule. What do we have in this? In this, if you have to differentiate, okay, constant multiplied with a function, then what should we do? We keep constant outside and we differentiate only the function. Confusing? One example. If you have to differentiate 5 x to the power 4, what should I do? I should keep 5 is outside constant, no? 5 I'll keep it outside. Differentiate only x to the power 4. Let me write that. Differentiation of x to the power 4 equal to 5 into, what is the differentiation of x to the power 4? 4 into x to the power 4 minus 1, 3. Correct? Which one have I used? X to the power n. N into x to the power n minus 1. Finally, simplifying this, you get 20x cubed. I repeat, I've used x to the power n into x to the power n minus 1. One more example is required over here. Perfect. Let's take differentiation of 6 log x. We know that 6 is a constant. Then we have log x. What is the differentiation of log x? 1 by x. But let's follow the steps. Keep the constant outside. 6 is outside. And we'll differentiate only log x. Correct? So we have 6. Differentiation of log x is into 1 by x. Differentiation of log x is 1 by x. 6 into 1 by x is 6 by x. And this is the final answer. One more example. Let's take differentiation of 2e to the power x. Fine. 2e to the power x. 2 is constant. Keep it outside. 2 differentiation of e to the power x. So differentiation of e to the power x is e to the power x itself, and we have got the answer. Fine. Let's take one more example. We have differentiation of, let's say, 3 root x. Fine. Differentiation of 3 root x. Now root x can be written as x to the power 1 by 2. But then I've already given you in the formula itself, root x is 1 by 2 root x. Correct? We'll go back to that page if you want. Root x is 1 by 2 root x. It's over here. Root x is equal to 1 by 2 root x. So we have 3 constant outside. Then we'll differentiate only root x. So we get 3 outside, 1 by 2 root x. Final answer is 3 by 2 root x. Clear? I think these 4 examples are enough for a constant function. It's basically all that I've done is keep the constant outside and differentiate only the function. Going smoothly so far. Constant rule is done. We have just 4 more rules. We go to sum rule. This is the second one. Okay. We have sum rule. This is also very easy. All that you need to do. See, if at all we have to differentiate one function plus another function. Okay, I'm putting a square bracket for this. Differentiation of first function, second function. Then what do we need to do? This is equal to differentiation of first function plus differentiation of second function. Is it only for sum? No, it is also for difference. So we'll call it as sum rule and difference rule. Now I'll make the change. Difference rule. So is it only plus? No, there is minus as well. Plus or minus. Let's see how it works. Not very difficult. Okay. So we have first one example. Let's differentiate log x plus x to the power 3. Okay, simple one I've taken, log x plus x to the power 3. What should we do? We should differentiate log x plus we should differentiate x to the power 3. Differentiation of log x is 1 by x plus differentiation of x cube is, it is in the form of x to the power n, 3 into x to the power 3 minus 1 is equal to 2. That's it. Do you want to simplify this further? Common denominator would be x. We have 1 plus 3x cube if required. Depending on the options, we will be simplifying, not required. We'll take more example right now. Okay, let's say we have to differentiate. Now what I'll do is I'll merge a little bit of constant rule also. Okay, let's say we have 3 by x. Okay, 3 by x, and this time I'll put minus. We will take 4e to the power x. 4e to the power x. I'll put plus also here. Plus I will put 9 root x. Okay, so I'm basically covering 3 over here. Plus also is covered, minus is covered, another 3 different types I'm also covering over here only. So differentiation of this, what do you do? First step is we need to individually write differentiation of 3 by x minus differentiation of e to the power x plus differentiation of 9 root x. Clear? Now constant rule is there, so we'll take 3 outside. differentiation of 1 by x is minus 1 by x square. Minus 1 by x square minus differentiation of e to the power x is e to the power x only. Or did I leave 4 there? Yes, 4 I have left. No? Okay. Now I'll add that. 4 e to the power x plus 9 is constant. Keep it outside. Differentiation of root x is 1 by 2 root x. Do you want me to simplify this further? Minus 1 into 3 is 3. So we have 3 by x square minus 4 e to the power x plus 9 by 2 root x. We will not simplify it further over here. Differentiation is complete. After this, it is like how we used to solve equations. So sum rule is covered. Difference rule is also covered over here only. So what did we study so far? Let's quickly revise. Otherwise, there is a possibility that it get lost. Basic rules, the formula, what we call. Okay, we have x to the power n into x to the power n minus 1. Differentiation of x is 1. Differentiation of 1 by x is minus 1 by x square. Differentiation of root x is 1 by 2 root x. Differentiation of e to the power x is e to the power x. Differentiation of a to the power x is a to the power x log a to the base e. Differentiation of constant is 0. Differentiation of log x is 1 by x. You need to memorize this. Okay, be comfortable with this, otherwise when I solve you may get lost. Then we started with the rules. First one was constant rule. Keep the constant outside. Differentiate only the function. We did that. Sum and difference. We differentiated each of them separately, then added it. Fine. That's all that we have done so far. We'll move on to the next rule. Rule number 3. Sum is done. Difference is done. Take a guess. Yes, that's right. We have product rule. Sum was straightforward, right? We differentiated separately, added it. Difference was straightforward, separately, then directly we took the difference. Constant also was simple, we kept the constant outside. But product, small change is there. If at all we have to differentiate f of x into g of x. Differentiation of f of x into g of x. What do we need to do? Differentiate f of x. Differentiate f of x. We keep g of x as it is. Plus, now we differentiate g of x. We keep f of x as it is. Okay. We'll put it this way. First function, second function. Easier to understand. We differentiate first function, second function as it is. Then we differentiate second function, first function as it is. Fine. How does it work? We'll see. Let's take one example. Let's say we have x log x. I kept a very simple example. X log x. What do we have to do for this? We have to differentiate. Differentiation of x log x. Fine. Okay. Now equal to. Now I'll highlight, okay, two functions that we have. I'll use it right over here. First function is x. I'll call it as first function. And we have log x. This is the second function. One is f of x, one is g of x. Correct? First function, second function. What should we do? We will split it now. We will write it as differentiation of first function. Second function, don't differentiate. As it is. So log x, keep as it is. Plus differentiation of second function. Differentiation of log x. First function as it is. What was the first function? X. Correct. Now differentiation of x is, I've already told you, it is equal to 1. Differentiation of log x is 1 by x, but we don't have to differentiate, so it becomes 1 into log x. Okay. Plus differentiation of log x is 1 by x. X we have to leave as it is, so x and x cancels. So what we get is log x plus 1. This is the final answer. One more is required, right? To understand it better, let's say we have to differentiate 3 e to the power x, 3 e to the power x plus 5. 3 e to the power x plus 5. I'm taking it slightly to the higher level. Okay. And then this should be taken with the product of 7 to the power x. Okay, slightly lengthier problem. So we have two functions, let's identify them. This is the first function. So I've used constant rule over here. I've also put some pluses there in the middle. Okay. In the second function, I did not keep much. So we have first function, we have second function. Now, what does the rule say? We should differentiate first function. Okay, we'll follow the steps, no shortcuts for now. Second function as it is, 7 to the power x as it is. Then plus differentiate second function, that is 7 to the power x. First function as it is, 3 into e to the power x plus 5. Okay, make sure you put these brackets, otherwise it look like differentiating both of them. Now tell me differentiation of 3 e to the power x. So 3 should be kept outside. Differentiation of e to the power x is e to the power x. Perfect. That is constant rule. Differentiation of 5. Constant. Constant differentiation is 0. Bracket. Don't miss. 7 to the power x as it is. Second function as it is. Plus. Differentiation of 7 to the power x. That is equal to 7 to the power x log 7 to the base e. How did I get this? How did I get this? This is from a to the power x. Differentiation of a to the power x is a to the power x log a to the base e. Fine. And that should be multiplied with 3 e to the power x plus 5. I'm going to stop over here. I'm not going to simplify it further. If you actually see 7 to the power x is common in both the terms between in either sides of plus, but I'm not going to simplify. When we have the options, we can simplify. Here my job is only to teach differentiation. Once you get the differentiation and later when there are questions with options, we can adjust it accordingly to get the right answer by simplification like we did in all other chapters. Okay. Let us take one more example. Okay. Let's take 5x cube, okay, into log x. 5x cube into log x, we have to differentiate this d by dx. Find differentiation of this. Two functions to be identified first. We have first function, we have second function. Okay, now this is the third problem. So let us do it little fast. Fine. So what should we do? The rule is differentiate first function. What is the differentiation of first function? 5 as it is, because it is the constant. Differentiation of x cube is 3x square. How did I get this? X to the power n. N into x to the power n minus 1. Fine. This is just differentiation of first function. Second function as it is. Product rule says differentiation of first function into second function as it is, plus differentiation of second function, differentiation of log x, 1 by x, and then first function as it is. Let me just simplify to one more step, okay, because I can see 5 and 3, we'll write it together. 15x square log x, and then one of the x cancels, plus 5x square. Oh, I think I can simplify it further. So we will take 5x square, which is common in both outside, and what remains inside is 3. 3 remains, and log x also remains, plus 1. So we have got the answer. I didn't want to simplify, but as I saw it was getting easier and easier, so I felt like simplifying and got the final answer as well. This is product. We'll go to quotient rule first, and then I'll come back to the entire revision once again, because more and more number of times we repeat, only then we will get comfortable with these questions. We'll go to the fourth rule now, quotient rule. As you understand, quotient means function divided by function. So if I have differentiation of f of x divided by g of x, differentiation of f of x, g of x. But I feel it is better we say numerator and denominator. Or you can say first function and second function, because in product I say first function, second function. With the quotient usually I say numerator and denominator. What is the rule? The rule says you differentiate numerator f of x. Denominator you leave as it is. Oh, we did something like this even in product. But in product we had plus after that. Now we have minus. Differentiation of denominator, that is the second function, into first function as it is. F of x I'll leave as it is. So you may think, okay, it's similar to product. Product it is plus, here it is minus. No, here we make a small change. Here we have divided by second function, that is denominator, whole square. Should we differentiate it? No, just square it. I repeat again, differentiate numerator, denominator as it is, minus differentiation of denominator, numerator as it is, all divided by denominator square. Fine. Has to be taken one example. So we will take one differentiation of, it has to be a simple one, right? First question, let's take root x. Let me put one number for this. Okay, 2 root x. Okay, 2 root x by 2 to the power x. 2 root x by 2 to the power x. Simplify this. I will have to expand it first. Differentiation of numerator, 2 root x. Denominator as it is, minus differentiation of denominator. Differentiation of denominator is 2 to the power x. Numerator as it is. Make sure you put these brackets, okay? Numerator as it is, 2 root x. All divided by denominator square. Denominator is 2 to the power x, right? 2 to the power x whole square. Fine. Now simplifying this, 2 root x, keep 2 outside. Differentiation of root x is 1 by 2 root x. 1 by 2 root x. Now this will be multiplied with 2 to the power x, because that is the denominator, minus differentiation of 2 to the power x is 2 to the power x log 2, and first function as it is, all divided by 2, x whole square was there, so we can write it as 2 to the power 2x. I'm not going to simplify further over here, okay, because when there are options we can simplify. As I told you, here it's only about differentiation. Rule you should remember: differentiate numerator, denominator as it is, differentiate denominator, numerator as it is, all divided by denominator square. We'll take one more example over here. Differentiation of, let's say, log x plus 2x. Log x plus 2x, I'm taking a little complicated one now, divided by e to the power x. This time I'll take minus e to the power x minus, which one do I cover? Log x is covered. Okay, we'll take a to the power x also. 7 to the power x. Fine. So there is numerator, there is denominator. We need to differentiate this. I may need more space, so I'm starting from the next line. Okay, so differentiate numerator. I'll write the rule first. This is numerator, the entire thing. Okay, into denominator as it is, no change over here, minus, we need to differentiate denominator, okay, numerator as it is, okay, and all divided by denominator square. Denominator square. Fine. Okay, now tell me, numerator we have differentiation of log x, 1 by x. Differentiation of 2x is 2. Correct? 2 is constant. Differentiation of x is 1. So this is done. Into e to the power x minus 7 to the power x, because it is as it is. I'm not going to simplify. Minus, we have e to the power x. Differentiation of e to the power x is e to the power x minus differentiation of 7 to the power x is 7 to the power x log 7. This is the differentiation now. and remaining all the remaining thing as it is. Only where I have to differentiate, I'm differentiate. So if you know differentiation, the basic rules and that whatever you have done so far, you'll be able to solve up till here. I hope it's clear. So what have you learned so far? We have learned some standard rules, okay, and then laws of differentiation. As I told you, a quick revision now once again. Fine, let me not keep it on the screen. We'll start with x to the power n. N into x to the power n minus 1. Differentiation of x equal to 1. Differentiation of 1 by x, we get minus 1 by x squared. Differentiation of root x, 1 by 2 root x. Differentiation of log x, 1 by x. Differentiation of e to the power x, e to the power x. Differentiation of a to the power x, a to the power x log a. Differentiation of constant 0. Correct? Yes, we can do it. Now coming to rules. First we have constant rule. Keep the constant outside, differentiate function. Then we have sum and difference. Normally differentiate them, then take sum or difference. Coming to product rule, if you have function into function, we'll say it as first function, second function, okay? Differentiation of first function, second function as it is, plus differentiation of second function, first function as it is. Last, so far what we did was quotient rule. We have numerator, denominator here. Differentiation of numerator, denominator as it is. Differentiation of denominator, numerator as it is. There is minus sign in between. Whole divided by denominator square. I hope this much is clear, because what we're going to do next is slightly at a higher level. It is part of the next rule. We'll go to the next rule, that is chain rule. Okay. Now the difficulty level is going slightly higher, so concentrate properly. Now let's say we have a function inside a function, something which we studied in functions composite function, that is f of g of x, function inside a function. If we have to differentiate this, that is d by dx of this function. First step what I'm going to do is I'm going to write z is equal to g of x. Z is equal to g of x. So now I can rewrite this as, wherever there is x, see I'm highlighting, wherever there is g of x, I'm replacing that with z. So it becomes f of z. From where did I substitute? What I have written on the right side, same thing I have substituted. So when x is independent, we take d by dx, correct? So this becomes d by dz. D by dz. So we find d by dz of f of z. But we have substituted something, right? So this becomes into, now we have to differentiate that separate equation that we had taken, z is equal to g of x. So that inside ka function has to be differentiated again. So this becomes dz by dx. Dz by dx. How is that? Differentiation of z with respect to x. This looks a little confusing. So we'll take a numerical. It is not that difficult. Okay. I will take a numerical to explain this. Let's say we have an example. Log 2x. Log 2x. We have to differentiate this. Okay. So let me put it this way. From now on, I will write it this way. Y is equal to log 2x. Because now from now on I'm gonna say we have to differentiate both the sides. Now differentiation of left hand side, y. Differentiation of y is dy by dx. Differentiation of y with respect to x is equal to, now we have log 2x. It is in the form of log x, correct? But it is not x, but instead of x we have 2x. And I have told you once with x is a function, a separate function. So 2x is a function, correct? Yes. So first we will differentiate thinking that it is x. Differentiation of log 2x. Differentiation of log x is 1 by x. So this becomes 1 by 2x. Instead of x we have 2x. Correct. Further, now we need to differentiate 2x. Differentiation of 2x is 2. That's the chain rule that I was talking about. Now 2 and 2 cancels, we get 1 by x. Clear? We'll solve one more now. We'll take y is equal to, from now on I told you already, y is equal to e to the power 5x. I'm taking simple ones only for now. E to the power 5x. Differentiate left hand side, dy by dx equal to. I will highlight now this separate function that we have. This is in the form of e to the power x. Correct? Okay. What is the differentiation of e to the power x? We have e to the power x only. Differentiation of e to the power x is e to the power x, but instead of x we have 5x. So write e to the power 5x into differentiation of 5x now. Differentiation of 5x is 5. So it becomes 5 into e to the power 5x. So what should we do? We should assume that it is a separate function, differentiate it, and then differentiate the separated function. More examples are required over here. Definitely, we will solve more. Let's take log x to the power 3. Log x to the power 3. Correct. I will also write y is equal to, okay, y is equal to log x to the power 3. Now this is in which form? We have function to the power constant. Correct. So I'll highlight this. Okay. Fine. Now left hand side, dy by dx. Differentiation, if it was x to the power 3, what would we write? N into x to the power n minus 1, that is 3 into, instead of x we have log x, 3 into log x to the power 3 minus 1, 2. Highlighted part, you need to differentiate again into differentiation of log x is 1 by x. Clear? More questions required? Yes. Okay. We'll take y is equal to e to the power log x. Y is equal to e to the power log x. Now this is in which form? It is in the form of e to the power function. Function means variable is there. Okay. E to the power x. See, this I will highlight now. What is the differentiation of e to the power x? It is e to the power x only. But log x I have highlighted now. Into differentiation of log x is 1 by x. Left hand side we get dy by dx. Clear? More questions? We will take y is equal to root 7x plus 1. Okay, root 7x plus 1. There is some rule also that I have included over here. Left hand side, differentiation of y is equal to dy by dx equal to. Now this is in the form of root x. So instead of x we have this entire thing, right? Entire thing should be highlighted. Now differentiation of root x is 1 by 2 root. 1 by 2 root. Instead of x we have 7x plus 1. Now differentiate 7x plus 1. I'll put a bracket. Differentiation of 7x is 7. Differentiation of 1 is 0. So final answer would be 7 divided by 2 root 7x plus 1. Getting better, definitely. Now one more. Y is equal to log. We will take e to the power x. Y is equal to log e to the power x. Now this is in the form of log x. Differentiation of log x 1 by x. But instead of x we have e to the power x, right? First we take it as x, then whatever is there as x we substitute that. Differentiation of log x is 1 by x. Differentiation of log e to the power x is 1 by e to the power x. Now differentiate e to the power x. Differentiation of e to the power x is e to the power x. Now this cancels, answer is equal to 1. Differentiation on left hand side, dy by dx. Now I'll try to combine even product rule over here. Okay, we'll put y is equal to, I want chain rule as well as product rule. So we'll take 4x to the power 5. Okay, into log we will take e to the power x plus we can take root 2, no, root x will take e to the power x into root x plus 9. Okay, little lengthy one I'm making over here, plus 9. This entire thing is within the bracket. Fine, so this is the question. Okay, so first left hand side will differentiate dy by dx. Differentiation of y with respect to x is equal to, how many functions do we have? We have the first function, like I did earlier, I'm gonna mark it as the first function, and we have the second function over here. Okay, fine, we'll follow the rule now. We will differentiate first function, second function as it is, differentiate second function, first function as it is. I'm using which rule? Product rule. Okay, so should I write that or I will do it directly, right? Okay, so differentiation of first function, second function as it is. Okay, I still wrote it down so that you get comfortable. Okay, plus differentiation of second function d by dx of first function as it is. I'm rewriting that. Okay, first function as it is. I'll adjust the space here. Okay, differentiation of first function of 4x to the power 5. Fine. Differentiation of first function into second function as it is, differentiation of second function into first function as it is. Now tell me, differentiation of 4x to the power 5. Chain rule. It is x to the power 5. What is x to the power 5? 5 into x to the power, instead of x we have 4x. 5 minus 1, 4. Correct. I'll keep it inside the bracket, remaining as it is in this part. Correct. Okay. Now differentiate this e to the power x. Differentiation of e to the power x is e to the power x. Differentiation of root x is 1 by 2 root x, and differentiation of 9 is 0. And 4x to the power 5. This is the final answer. Okay, one more question we'll take. We'll try to take a quotient rule also, because some have taken, maybe have not taken difference so far. I can try to include difference also in this only. Product we have taken, now we'll take a quotient. So we'll take y is equal to log root x should be enough. Okay, and divided by, we will take e to the power 3x plus 5, and we'll cover the this rule also, difference rule in this only. I know it will get a little lengthy, but that's fine, I guess. Okay, then we'll cover minus, we will go for log is taken, we'll take x to the power. Okay, so we have 5 to the power x, 5 to the power x plus 2. Okay, 5 to the power x plus 2. This much I think is enough in this particular question. So prepare the question, we'll try to get the answer now. Differentiation of the left hand side, dy by dx equal to, I'll push it to the side, I know more space is required. Differentiation of numerator. We are in the initial stages, so I'm writing everything. Differentiation of numerator, bracket, denominator as it is, e to the power 3x plus 5 minus 5 into 5 to the power x plus 2. Correct, this entire thing, minus differentiation of d by dx of e to the power 3x plus 5, differentiation of this, no, there's one more thing missing right here, minus 5 into x, 5 to the power x plus 2, differentiation of this numerator as it is, log root x. Make sure you put this bracket. Not done, denominator square. That should be done quickly. Denominator whole square. Fine. We have not differentiated. I've just expanded. I've applied the rule. Now we will differentiate. Differentiation of log root x. It is in the form of log x. Differentiation of log x is 1 by x, but instead of x we have root x. Correct? Further, we are applying chain rule. We assume that it is x now. So differentiation of root x is 1 by 2 root x. Differentiation of numerator is complete. Denominator as it is. This is copy paste. Okay. Now differentiation of denominator. Minus sign is there. Make sure you don't leave it out. E to the power, I'll highlight it, e to the power 3x plus 5. So it is in the form of e to the power x. Differentiation of e to the power x is e to the power x only. So it comes same 3x plus 5. Okay. Into, we are applying chain rule now. Differentiation of 3x is 3. Differentiation of 5 is 0. Square bracket. No, I have not completed it. Okay. Minus differentiation of 5 to the power x plus 2. Again, we have chain rule. What is the differentiation of 5 to the power x? It's 5 to the power x, but instead of x, we have x plus 2. 5 to the power x log 5 to the base e. Further, this should be multiplied with the differentiation of x plus 2. Differentiation of x plus 2 is 1 plus 0. Correct? For this entire thing, now the square bracket closes into the second function, log root x. Is it over? All divided by e to the power 3x plus 5 minus 5 into x plus 2. This we are not simplifying, whole square. I made it a little lengthy. I hope it's clear. I've written it in 2 lines, even the numerator, but I hope that's not gonna confuse you. Fine. Do it slowly. Differentiate numerator, denominator as it is. Differentiate denominator, numerator as it is, divided by denominator square. More questions are there later in the exercise, so that should be enough for now. Okay. Now I will take some combined questions and then we'll see if we can solve them, not related to the topic. Okay. Then we will go to the main questions. So before I move to some combined questions, let's quickly revise. I'll only revise the rules for now. Okay. We have constant rule, keep constant outside, differentiate function. Sum and difference, separately differentiate, add or subtract. Product rule, differentiate numerator. Product rule, differentiate the first function, second function as it is, plus differentiation of second function, first function as it is. And last we had the quotient rule. We had differentiation of first function, second function as it is, minus differentiation of second function, first function as it is, all divided by denominator square. Not the last one. Then we had chain rule. Chain rule, we differentiate thinking that it is a separate function. We assume that to be the separate function, and then separately the function is differentiated. So this is what we have done so far. Couple of more questions. I told you I'll take combined questions, not specific to any particular rule now. Basically, all different things will be used over here. Let's consider one example now. Okay, we will take y is equal to 2x divided by 3x cube, and I will take plus, we will take e to the power 4x. Fine, no? Okay, so basically I have put it up for the quotient rule is there in this. Chain rule also I have covered it in this particular problem. Fine. So differentiation of y is dy by dx. Okay. Differentiate numerator. Now I'm not gonna write that expansion form and all. Okay, we are going a little faster now. Differentiation of numerator. Differentiation of 2x is 2. Correct? Numerator. Into denominator as it is. Differentiation of numerator into denominator as it is, minus differentiation of denominator, differentiation of 3x cube. 3 into constant rule, right? 3x square. Differentiation of 3x cube is 3x square. How did I get that? X cube is n into x to the power n, n into x to the power n minus 1. So 3 into x to the power 3 minus 1 is 2. Okay. plus differentiation of e to the power 4x, that is equal to e to the power 4x. It is in the form of e to the power x, so e to the power 4x, differentiation of 4x is into 4. This is differentiation of denominator. A big bracket is required over here because there is negative sign outside, remember that. Entire thing of differentiation is done. Then numerator as it is, all divided by denominator square. Denominator square. In the questions that we have, we may have to simplify further. Here, my job is only to do the differentiation using rules and standard formula that I have given. We'll take one more example. Y is equal to, we will take e to the power x log x. A comparatively simpler question, okay? Product rule. Dy by dx. What do we do in product rule? Differentiation of first function. Differentiation of e to the power x is e to the power x. Second function as it is. Plus differentiation of second function. Differentiation of log x is 1 by x. First function as it is, e to the power x. If I have to simplify, since I can see it over here, e to the power x is common, we get log x plus 1 by x. This is the final answer. I'll just take two more questions now. Okay, then we'll go to the exercise. We will now take another question, 3 to the power log x, okay, into log x plus 2. We'll do log x square plus 2, okay, log x square plus 2, okay, fine. This is the question. So I've tried to include chain rule over here, and it is also product function. Okay, so we have two functions. We'll identify them again. Okay, we have two functions. I'm not gonna write anymore. Differentiate first function. Differentiation of 3 to the power log x. Log x is a separate function. Correct. So differentiation of log 3 to the power x is 3 to the power x. Instead of x, we have log x. 3 to the power x log 3. Is it done? No, we have to differentiate log x now. Differentiation of log x is 1 by x. Clear? Now what do we do? Second function as it is. This is just differentiation of first function. Second function as it is, I have written. Okay, done. Plus differentiation of second function. It is in the form of log x. Differentiation of log x, 1 by x. Differentiation of log x is 1 by x. But was it really log x? No, it was x square plus 2. Differentiation of x square is 2x. X to the power n, n into x to the power n minus 1, 2x. Plus differentiation of 2 is 0, which is a constant. The differentiation of second function is now complete into first function. Solution complete. One more. I know you are waiting for actual questions, but we'll solve one more question, okay? So we have a simple question now. Y is equal to, I will take 3x square plus 5x plus 7, okay? Well, this is a very simple question. Probably should have come in the very beginning, okay? But just before we start the actual questions, we are gonna solve this. Differentiation of left hand side, dy by dx equal to differentiation of 3x square, 3 outside, differentiation of x square is 2x, plus differentiation of 5x, 5 outside, differentiation of x is equal to 1, differentiation of constant 0, 2 into 3, 6x plus 5 is the final answer. So with all the rules that we have learned, taking help of the standard formula that we have, we will now start solving. But before that, a very quick revision. So let's do it together. We'll start with differentiation of x to the power n. Differentiation of x to the power n is n into x to the power n minus 1. Differentiation of x is equal to 1. Differentiation of 1 by x is equal to minus 1 by x squared. Differentiation of root x, 1 by 2 root x. Differentiation of e to the power x is e to the power x. Differentiation of a to the power x is a to the power x log a to the base e. Differentiation of log x is 1 by x. I have covered all of that. Let me just again put it back on the screen. Okay, which I had written earlier. Yes, here it is. So this is all that we have. Yes, definitely I have missed out a differentiation of constant which is equal to 0. Then we went to constant rule where we have constant and a function. So we keep the constant outside as you see on the screen and we differentiate only the function. Then we went to sum and difference. We differentiate them separately, add and subtract as the case may be. Then we have product rule. Differentiate first function, second function as it is. Differentiate second function, first function as it is. It's there on the screen now. Then we went to quotient rule. It's a little lengthier, but if you actually see, it's easy. We'll go by numerator, denominator. Differentiation of numerator, denominator as it is, minus differentiation of denominator, numerator as it is. All divided by denominator square. Chain rule, where it can be little confusing. So we'll not go by f of x, g of x now. Okay. What we'll do is, we will identify the function. Function is where we have a variable. Okay. We'll see if you can solve it directly. If you cannot, if you think that there's another function, then what we do is we take that as the only function. We differentiate it thinking that is the only function. You see the highlighting. I'll continue highlighting in all the problems. Then what do? We differentiate the highlighted part. That is the separate function. Chain rule. So that's all that we studied so far. And we are now good to solve questions. Yes. First question. The gradient of the curve. I don't know what is this gradient. Gradient is nothing but the slope of the curve or the tangent of the curve. We don't have to worry much. Okay. Basically, we find it through differentiation only. Basically, we have to differentiate the given curve and then it continues. The curve is given. Okay. Y is equal to 2x cube minus 3x square minus 12x plus 8 at x equal to 0. So what we should do is first we will differentiate it. After that, after differentiating, we'll substitute x equal to 0 because that's where they are asking for it. Okay. So differentiate, you do both sides. Differentiation of y is dy by dx equal to differentiation of 2x cube. That is 2 into 3x square. Differentiation of x cube is 3x square minus differentiation of 3x square. Now 3 outside. Differentiation of x square is 2x minus differentiation of 12x is 12 into 1 and differentiation of 8 is equal to 0. Just simplifying this, you get 6x square minus 6x minus 12. Now this is dy by dx. We want at x equal to 0. So we write dy by dx at x equal to 0. Substituting x equal to 0, we get 6 into 0 square minus 6 into 0 minus 12. Final answer minus 12. I hope it's clear. Basic differentiation only will be there over here. It's not going to be too complicated. Question number 2. Very similar question. Okay. Gradient of the curve again. See, now we will use a little bit of shortcut. Okay. This is x equal to 0 because we know whatever is multiplied with 0 will be 0 only. So if you see, we have x cube over here. When we differentiate, we still have x square. It becomes 3x square. We have x square over here. When we differentiate, we get 2x. Still x is there. But when we differentiate minus 3x, we get minus 3 into 1. Correct? So what do you think is the answer? Minus 3. Directly. Okay. But then I still differentiate and show it to you. Differentiation of left hand side dy by dx. Differentiation of 2x cube. 2 into differentiation of x cube is 3x square. Okay. Minus 5 outside constant rule. Differentiation of x square is 2x. Minus 3 outside differentiation of x is equal to 1. Now directly I will substitute. Okay. Dy by dx at x equal to 0. What do we get? we get 6 into 0 square minus 5 into 2 is 10. 10 into 0 minus 3. So final answer is minus 3, which I have already marked as the right answer. Okay. So gradient of the curve. But what I suggest is after this, if you get a question on gradient of the curve where we have x, where we don't have higher powers, only where we have x, because we know differentiation of x is equal to 1. Whatever is the coefficient of x, that itself will be the answer. Coefficient of x will be the answer. Here also coefficient of x is the answer. 2 questions done. We'll move on to the next question. The derivative of y is equal to root x plus 1. Left hand side, dy by dx equal to. Which rule are we applying? It is in the form of root x. Correct? So this part. What is the differentiation of root x? 1 by 2 root. Do we have x? No, instead of x we have x plus 1. Now we need to differentiate the highlighted part. Differentiation of x plus 1 is 1 plus 0. So 1 plus 0 is anyways 1. So we get 1 by 2 root x plus 1 as the answer. Option C is the right answer. Moving on, question number 4. F of x is there. E into a x square plus bx plus c, then f dash of x. That is nothing but differentiation only. Okay. So differentiating f of x, we get f dash of x. So we get f dash of x equal to same as dy by dx, f dash of x. So e to the power x, it is in the form of chain rule. It is in the form of e to the power x. Differentiation of e to the power x is e to the power x only. So as it is. Differentiation of e to the power x is e to the power x. But then we are not really differentiating e to the power x. It is e to the power something else. What is that something else? We need to differentiate that something else. Differentiation of ax square. Remember, a is a constant. Differentiation of x square is 2x. Differentiation of bx, b is constant, x as it is. Differentiation of x is 1, b into 1, plus differentiation of c is 0. Okay, just to simplify this further, we have e to the power ax square plus bx plus c into, we'll write the number first, 2ax plus b is the final answer. Do we have that in the option? Yes, option B is the right answer. Moving on to the next question, we have f of x, x square plus 1, x square minus 1. So we have function divided by function, quotient rule. So we'll do it directly, right? Without writing down the differentiation of first function into second function and so on. Okay, anyways, I'll just repeat it for you. When we have function divided by function, we need to take numerator denominator. So differentiation of numerator denominator as it is minus differentiation of denominator numerator as it is, whole divided by denominator square. Fine. So we have left hand side f of x, right? Differentiation of f of x is f dash of x equal to differentiation of numerator. Differentiation of x square is 2x. Differentiation of 1 is 0. This is the differentiation of numerator. Completed. Okay. Now denominator as it is. Minus. Differentiation of denominator. 2x minus 0. Differentiation of denominator. Numerator as it is. Okay. Whole divided by denominator square. Now, if you see in the options, in first option, second option, third option, A, B, C, denominator is sorted. It's matching. So it's all about numerator now. Let's simplify this. Okay. So far in the examples, we should not simplify. We should leave it as it is. So we have 2x into x square. No, I think 2x we have on both sides, right? So we can take 2x outside the bracket. So what remains inside? X square minus 1 and minus x square minus of plus 1 is another minus 1 over here. Fine. Whole divided by x square minus 1 whole square. That is not a problem. Denominator is not my problem because it is there in all the options. Fine. So further, x square positive and negative cancels. Minus 1 is minus 2. Minus 2 into 2x is minus 4x divided by x square minus 1 whole square minus 4x x square minus 1. Yes, we have it in option A. So once you know the first step, that is differentiation, after that all that we did from first chapter to 8th chapter, simplification. In fact, 7th chapter. Y is equal to, so we have y is equal to x into x minus 1, x minus 2. We need to find differentiation of y with respect to x. So now do not think it is three functions, product of three functions, x, x minus 1, x minus 2. Can be done that way. Then we will take first two as one function and then we have another function. Then again between those first two we have to take product function. Gets very lengthy. So what he'll do is here, since we know we can open the bracket, we may get a simpler equation. So I'll rewrite this y is equal to x. I'm not simplifying, okay? I'm just rewriting. Okay, y is equal to, now simplifying. Open the bracket, we get x square minus x. Only first two I'm doing at a time, step by step. Now again I'll open the bracket, first into first, x square into x, x cube minus 2x square minus x into x minus x square, and we are minus into minus plus 2x. Y is equal to x cube minus 3x square plus 2x. So simplification is done. Have I differentiated it? No. So this is like equations, what we are doing so far. Now we'll differentiate. When you differentiate, we do the same thing on both the sides. Differentiation of left hand side, dy by dx equal to differentiation of x cubed 3x square minus 3 outside, differentiation of x square is 2x, differentiation of 2x is 2. Okay, we'll search for the answer. Yes, we know we are coming close to the right answer. 3x square minus 6x plus 2. Option A. Okay, so we have to simplify first and then differentiate. You get the answer. Question number 7. Xy is equal to 1. And then they have asked for xy square plus dy by dx. Requirement is y square plus dy by dx. So somewhere dy by dx is there. Correct? Okay. So the given question is xy is equal to 1. Is there a way to differentiate this xy when they are together? There is. I have not taught you that yet. Oh yeah, there is more in differentiation. That will come in the second part in the bird's eye view that I have shown you. But for now, what can we do? We can write this as y is equal to 1 by x. Now it's a simple equation and we know the value of this. Now differentiate both sides. We get dy by dx equal to differentiation of 1 by x is minus 1 by x square. Done. Now this is not the requirement. Requirement says y square plus dy by dx. What is y? Y is 1 by x. Correct? From where I got this? Here. See, I'm highlighting now. This is y. This is the value of y. Correct? And this is the value of dy by dx. Correct? Okay. So now I'll substitute it. I get plus 1 by x square. Correct? Do we have that option? No, we need to simplify this further. Looks like, okay. So this is y square, right? Okay, I missed the square here. Okay. Now when I simplify this further, I get 1 by x square minus 1 by x square. Everything cancels. Answer is 0. Very happy to get the right answer. Smiley, 0. Correct? Okay. So in addition to getting dy by dx, they wanted us to square y and then add them up. Okay. Moving on to the next question. We have differentiation of a function root x plus root x. Definitely chain rule. Now see, if you remove the highlighted part and put it by as x, it looks like root x, right? Okay, so dy by dx is equal to differentiation of root x 1 by 2 root x plus root x. Now the highlighted part you will differentiate into differentiation of x is 1 plus differentiation of root x is 1 by 2 root x. Do we have that? Looks like we have it in option C. Yes, it's there in option C and that is the right answer. We'll move on. I hope I'm not going too fast. If you feel I'm going a little too fast, maybe you can pause the video, see the answer, and then solve. Maybe you can listen first, participate in the question, and then pause the video, and then you can copy it down as well or solve. Question number 9. Y is equal to 1 by root x. We know the differentiation of 1 by x. Differentiation of 1 by x is minus 1 by x square. Left hand side before that, dy by dx. We know 1 by x, so I'll consider this as x. Okay, differentiation of 1 by x is minus 1 by, instead of x we have root x square. Now we need to differentiate root x. Differentiation of root x, the highlighted part. 1 by 2 root x. Correct? What did I do first? I differentiated it like 1 by x. 1 by x is minus 1 by x square. Instead of x we put root x. Then the highlighted part we have to differentiate. Simplifying this further, minus 1 into 1 is minus 1. Okay. Root x square is x. 2 is there and we have root x. Okay. I've realigned it and we got the final answer. Answer is C. C is the right answer. Moving on to the next question, we have y is equal to her. There we go. We have numerator, we have denominator. Which rule? Quotient rule. We'll start from left side, okay? Because we know it is going to be lengthy. Dy by dx equal to. What do we do when you have function divided by function? Differentiation of numerator. First differentiation of numerator. Differentiation of e to the power 3x. So it becomes e to the power 3x into 3. Correct chain rule. E to the power 3x. It is in the form of e to the power x. Differentiation of e to the power x is e to the power x only. But instead of x we have 3x. Then we have to differentiate 3x. Differentiation of 3x is 3. Okay. Differentiation of e to the power 2x is e to the power 2x into 2. Correct. Same logic over here also. This is differentiation of numerator. Denominator as it is e to the power 3x plus e to the power 2x. Differentiation of numerator into denominator as it is minus big bracket we have to open over here, otherwise we will not multiply this minus sign with the other values. Differentiation of denominator e to the power 3x again we have, so we have e to the power 3x into 3 plus e to the power 2x into 2 right, okay, into 2. Okay, same as what we had earlier, so I've written it directly, but earlier it was minus, now it is plus. Okay, then another bracket and we have numerator as it is, big bracket closes, all divided by denominator square. Okay, with this the denominator itself I know it's not option A, not option B, sorry, not option C, because square is there. It could be B, it could be D also. Then you never know, it may cancel and we may get only numerator. That is also a possibility, but whatever it is we have to open the bracket now. So it's like first term into first term here, first term into second. I'm drawing the lines over here. Second into first and second into second. And same thing I have to do over here also. Okay, fine. So we'll have to find this. We'll do little slowly so that we do not go wrong. Okay, we have 3 into e to the power 3x, e to the power 3x, e to the power 6x. Loss of indices. Powers can be added and base is same. Okay. Mine plus, right? Plus, yes. Plus e to the power 3x, 3 into e to the power 5x. First into second, first is also done. First into first into second is done. Minus is there, e to the power 5x again. So 2 into, right? Yeah, 2 is there. 2 into e to the power 5x. Again minus is there, 2 into e to the power 4x. 2 into e to the power 4x. With that, we have finished one part of the numerator. Minus, big bracket opens now. Okay, we have 3 into e to the power 6x again. Correct? Okay, then we have minus 3 into e to the power 5x. Okay, plus we have 2 into e to the power 5x and we have minus 2 into e to the power 4x. Completed. Bracket is still there. Okay, in the next step only I will remove it. because all the signs will change because minus sign is there outside. All divided by my denominator is not creating any problem for now. Leave it as it is. Okay. Now we'll open the bracket only, then in the following step we will simplify further. Okay. We have 3 into e to the power 6x plus 3 into e to the power 5x minus 2 into e to the power 5x minus 2 into e to the power 4x minus 3 into e to the power 6x minus into minus becomes plus 3 e to the power 5x minus 2 e to the power 5x. See, minus sign is getting multiplied, 2 e to the power 4x. Okay. All divided by that is still continuing. We have e to the power 3x plus 2e into the power 2x whole square. Let me try to simplify. Let me check for the common things if they are with different signs. We have 2e to the power 5x negative, 2e to the power 4x positive, cancels. We have anything else? Okay, I think I cancelled the wrong one. This one, yes, this one is cancelled. Then we have another negative here over here and positive over here, that also cancels. We have 3 e to the power 6x positive. We have 3 e to the power 6x negative, that also cancels. And we have 3 e to the power 5x positive, 3 e to the power x positive, both places. Correct. So the final answer is that will not cancel because both are positive. So we have 6 e to the power 5x divided by e to the power 3x plus e to the power 2x whole square. Do we have that option? We do not have it in A, B and C. We have it as none of these. So what looked like answer will be down to B because denominator was their square. I gave you a clue also. Okay, it's not A, not B. I mean not A, not C. Maybe B, but it could be none of this. It is none of this. Answer is 6 e to the power 5x. This is just simplification. If you see what I'm highlighting now, this is differentiation. What I've done first. This is differentiation. Remaining has got nothing to do with differentiation. It is all that you have been doing all this while. That is simplification. That's your final answer. 6 e to the power 5x divided by denominator square. Moving on to the next question. Question number 11. Looks like something similar we have solved. Anyways, we'll solve it again. We have first function, second function, product rule. Anyways, y is not given, but we will still write dy by dx. Okay. Differentiation of x square is 2x. Log x as it is. Plus differentiation of log x is 1 by x. First function as it is. Differentiation is complete, but we now have to simplify. We have 2x log x. One of the x cancels over here. Denominator 1x is there. Numerator 2x's are there. Okay, 1x still remains. We can get that outside the bracket. We have 2 log x plus 1. Do we have this? We do have it in option B. It's written 1 plus 2 log x. It is same as 2 log x plus 1. And x being outside the bracket. 11th one is done. 12. Derivative of 3 minus 5x divided by 3 plus 5x. Correct. Looks like a quotient rule, right? Something which we had done. We had done some time back, very lengthy one, where we had e to the power x and all of that. Something similar, but you'll still follow the rules. Okay. Dy by dx, differentiation of y with respect to x. Quotient rule, differentiate numerator. Differentiation of 3 is 0. Differentiation of minus 5x is minus 5. That is constant into 1. I'm not going to write that after this. Okay, this is differentiation of numerator. Denominator as it is written minus differentiation of denominator 0 plus 5. Correct? Numerator as it is divided by denominator square. And looking at the options, option A, option B, option C, all have the right denominator. So now I know. Looks like when the numerator has to be solved properly, but we'll anyways do everything. So we have minus 5, open the bracket, minus 5 into 3, minus 15. Minus 5 into 5 minus 25x. Again we have minus outside bracket. Remember, minus 5 into 3, we have minus 15 again. We have minus 5 into minus 5x is plus 25x. Whole divided by denominator as it is. 25x positive and negative cancels. We get minus 30. And very happy to see that in the option. It's there in option C. Option C is the right answer. Minus 30 divided by 3 plus 5x whole square. Quotient rule. Moving on. Y is equal to root 2x plus 3 to the power 2x. dy by dx is required. Look simple. dy by dx equal to. We know the differentiation of root x, but here it is root 2x. So 2x is the internal function. We have to use chain rule. Differentiation of root x is 1 by 2 root x, but instead of x we have 2x. Now we need to differentiate 2x. Differentiation of 2x is equal to 2 plus some function 3 to the power 2x. Again we have to apply chain rule. It is in the function, it is in the form of a to the power x. Differentiation of a to the power x is a to the power x log a to the base e. Instead of a we have 3. Differentiation of 3 to the power 2x, 3 to the power 2x log 3 to the base e. But it is not 3 to the power x, it is 3 to the power 2x. So differentiate 2x again into 2. Differentiation of 2x is 2. Okay, do we have that in the options? Okay, so 2 is common. No, in fact this 2 cancels. No, this 2 and this 2 cancels. So what remains now? Equal to 1 by 2 root x plus 2 into 3 to the power 2x log 3. This is the final answer. That is not 2 point. Okay, that is 2 into. Okay, 2 into 3 to the power 3 to the power 2x log 3. Looks like the option A is the right answer. Just confirming. Yes, option A is the right answer. So chain rule was there. In between the sum was also there, but you can do it separately and get the answer. That's question number 13. Moving on, question number 14. It is in the form of e to the power x. Chain rule. What is e to the power x? Differentiation of e to the power x is e to the power x. So we have e to the power 3x square minus 6x minus plus 2 whole into differentiation of 3x square 6x, differentiation of 6x minus 6, differentiation of 2 plus 0. So what's remaining now? We have e to the power 3x square minus 6x plus 2 into 6x minus 6, or we can take 6 outside the bracket also, I guess. Yes, 6 will take outside bracket. We have x minus 1. Do we have this in the option? So 6 is there outside the bracket, x minus 1 is there. Okay, fine. And e to the power thing is there in option C. Option C is the right answer. It's just the simplification that is done for 6x minus 6. Moving on to the next question, question number 15. We have y is equal to numerator, denominator. So we'll highlight numerator only. Okay, fine. So there is one function, remaining is other function. So we have dy by dx, left hand side. Okay, differentiation of numerator, differentiation of e to the power x is e to the power x, differentiation of 1 is plus 0. The differentiation of 1 is 0. Denominator as it is, minus differentiation of denominator. Okay, this is differentiation of denominator, e to the power x is e to the power x, differentiation of minus 1 is 0. Numerator as it is divided by denominator squared. Okay, let's check in the options. All the options have denominator square. Okay, now we'll open the bracket. E to the power x into e to the power x, e to the power 2x, e to the power x into minus 1 minus e to the power x, minus e to the power x into e to the power x, e to the power 2x, and we have minus e to the power x into 1, we have minus e to the power x. Whole divided by denominator as it is. Let's try to simplify now. We have 2x positive, 2x negative, that is e to the power 2x, e to the power minus e to the power 2x, both cancel. So what remains? Minus e to the power x, 2 times it is there. So 2 times e to the power, so minus 2 e to the power x divided by e to the power x minus 1 whole square. Do we have that option? Yes, we do. Yes, we do. We have option E as the right answer. So I think because of these questions, even the quotient rule is getting comfortable. Yes, differentiation of numerator, denominator as it is, differentiation of denominator, numerator as it is, separated by minus sign in the middle, all divided by differentiation, all divided by denominator square. So I think we solved at least 3 to 4 questions over here. First step is the differentiation, after that it is the simplification. Question number 16. F of x is equal to given something. They asked you to find f dash of 2. That means first we'll find f dash of x, that is differentiation. After that, we'll substitute x equal to 2. Okay. But before that, what I see over here is we have one value plus another value all square. We can do it. We can use chain rule. Correct? This can be taken as x square, which is 2x. Then we'll differentiate the inside part. Looks like it's gonna get a little more complicated. So what we'll do is first we'll simplify, because we know a plus b whole square formula. We know that. Okay, switch to pen. We know that a plus b whole square is equal to a square plus b square plus 2 times ab. This should make the equation simpler, I believe, because we have root x. When we square it becomes x. So we get f of x, I'm writing as it is, equal to, we have a square, that is root x whole square, plus b square 1 by root x whole square plus 2 times root x, and b is 1 by root x. Correct? Fine. So now it looks like a simpler equation. Simplifying further, root x square will be x, 1 by x square will be 1 by root x square will be 1 by x, okay, and root x cancels, plus 2. Wow, much easier. So f dash of x, that is differentiating now both the sides. Differentiation of x is 1 plus differentiation of 1 by x is minus 1 by x square. Differentiation of 2 is 0. Now we need f dash of 2. In place of x, substitute 2. Substituting x equal to 2. Okay, we have 1 minus 1 by 2 square. 2 square is equal to 4. 1 minus 1 by 4. From 1, if you reduce 1/4, you know we get 3/4, and 3/4 is there in option A. This is after differentiating, we substitute the value of x value. Okay. So here, even before differentiating, we simplified. So remember, sometimes if at all you can simplify before differentiating, go ahead. I think in another problem also we did that, right? Where we had product of 3 functions, x into something. So we simplified the equation, then we differentiated. So here also we are simplifying first and then we are differentiating. Moving on. Question number 17. F of x is given, looks like a simple one. They need f dash of 5 minus f dash of 8. Wait, I'll do one thing. I'll write the requirement first. F dash of 5 minus f dash of 8. This is the requirement. So first, I need to find f dash of 5. Then I need to find f dash of 8. Then take the difference. But before finding f dash of 5 and f dash of 8, I need to find f dash of x. That means I have to differentiate. So this is the requirement. Okay, we'll drag it like this because I'm going to substitute right under that. Okay, here I'll find out f dash of x. F dash of x is equal to, differentiate right hand side now. Differentiation of x square is 2x. Differentiation of 6x is minus 6. Differentiation of 8 is 0. Correct? So we get 2x minus 6. Now f dash of 5. 2 into 5 minus 6 minus f dash of 8. 2 into 8 minus 6. All that I've done in place of x, I've substituted the value after differentiating. Okay, 5 2s are 10, 10 minus 6 is 4, minus 8 2s are 16, 16 minus 6 is 16 minus 6 is 10. So 4 minus 10 is minus 6. Minus 6 is what I've got. But that option is also not there. Correct? Options that we have is f dash of 2. Can it be f dash of 2? Let me check. I will check the options now. I'm switching to red. Okay. Maybe for trial and error. F dash of 2 is equal to 2 into 2, right? F dash of 2. 2 into 2 minus 6. 2 2s are 4. 4 minus 6 is minus 2. Is it correct? No. So f dash of 2 is minus 2. So the answer should be, I think, second option, 3 into f dash of 2. I already know f dash of 2 is minus 2. 3 into minus 2 is minus 6. So this minus 6 and this minus 6 are matching. Okay, so what's the final answer? Final answer is 3 times f dash of 2. So we got the answer minus 6. It was not there. Then we tried different values. So basically f dash of 2 is all that we had to find out. Okay, so either it was f dash of 2 in option A, option B was 3 times f dash of 2, third option was 2 times f dash of 2. So everywhere it was there and we found the answer to be 3 times f dash of 2. That's number 17. Moving on to the next question, question number 18. F of x is equal to x to the power k. Okay, and f dash of 1 is equal to 10. The value of k is little confusing. So what we'll do is we'll first find out f dash of x. Then we know f dash of 1 can be found out. Okay. So f of x is given to be x to the power k. So f dash of x is equal to, we have to differentiate k into x to the power k minus 1. Correct. This is f dash of x. They said f dash of 1. That means in place of x we substitute 1. So we have k into 1 to the power k minus 1. 1 to the power anything is 1. So f dash of 1 is equal to k into 1 is k. They also said f dash of 1 is equal to 10. 10 is equal to k. Oh, we got the answer. K is equal to 10. Clear? So we simplified as we solved. We came closer to the answer. Answer is equal to 10. Moving on to the next question. Question number 19. Y is equal to e to the power x plus e to the power minus x. Then dy by dx minus something. Like something similar we had earlier also, right? So we had, I think, y square minus dy by dx, something like that. So that I'll first write the requirement of the question, dy by dx minus square root of y square minus 4. Okay, this is what I need to find out. I need to substitute. So we'll find dy by dx. We'll differentiate that y ka equation. Left hand side, dy by dx equal to differentiation of e to the power x, e to the power x. Differentiation of e to the power minus x. It is in the form of e to the power x, but instead of x, we have minus x. Correct? So we get e to the power minus x. Differentiation of minus x is 1. So we get 1 minus 1. I've changed the sign, so we get e to the power x minus e to the power minus x. Fine, this is dy by dx. Okay, now we need to find out dy by dx. So I'll substitute e to the power x minus e to the power minus x minus. We have square root of y square. What is y? Y is e to the power x plus e to the power minus x. What is given in the question? This is y square. So we have to square this minus 4. Correct? Okay, where y is there, I substituted the given question. Left hand side as it is e to the power x minus e to the power minus x. Oh, there is no left hand side, is it? Okay, that is the previous term. Apologies. Minus. Then we have to open the square inside square root. So we have a plus b whole square. So we have, this is a square plus this is b. So we got b square plus 2 times a b. Correct? So we just expanded, that is a plus b whole square.
a plus b whole square was expanded, a square plus b square plus 2ab. I've written that as well. Okay, I'll just highlight this part and I'll give the angle as well. Okay, this part is coming from here. Okay, expansion still not done. Minus 4 is there outside, so we'll continue with that minus 4 which is coming from above. Simplifying further, we get e to the power x minus e to the power minus x minus what remains inside e to the power x whole square, that is e to the power 2x plus e to the power minus 2x. Then we have plus 2 e to the power x, e to the power minus x, that cancels, correct? So we get equal to 1 minus 4. So we have two constants over there. 2 minus 4 is minus 2. So we have e to the power x minus e to the power minus x minus square root as it is. We have e to the power 2x plus e to the power minus 2x, correct? And then we have minus 2. So earlier we had plus 2, now we have minus 2. Now I can write the condensed form of this. What is the condensed form of a minus b? This is the expansion form. Okay, expansion form of a minus b whole square. We have a square plus b square minus 2ab, correct? Okay, so now I'll write the condensed form of a square plus b square minus 2ab. So e to the power x minus e to the power minus x minus square root of e to the power x minus e to the power minus x whole square, correct? Now if you see square and square root cancels, what remains is e to the power x minus e to the power minus x minus e to the power x is remaining inside minus e to the power minus x. Is it minus? No, plus, because minus sign is outside. So what remains? E to the power x positive, e to the power x negative, negative, positive, everything cancelled. Answer is 0. Answer is 0. I'll just repeat this part. This minus sign is outside. Be careful with this. When you multiply with the inside one, you get positive. That's how it becomes 0. But if you see, differentiation part was only the first one. This is the differentiation part. What I'm highlighting now, this was the differentiation part. Remaining is just the simplification. That differentiated part is simplified. I mean substituted and then simplified. That's it. Answer is 0. Moving on to the next question. Question number 20. We have x square minus 1 divided by x. Remember that divided by x is not just for 1 by x, it is for the entire thing. Okay, so it's a possibility of reading it differently. Like if you see the options also, all the options has x square in the denominator, so that's how they have written it. Like actually speaking, it is wrong because the bracket is missing, but still looking at the options, we see the denominator everywhere it is x square, and that you get in quotient rule. Okay, fine. Also, obviously, I've seen the answer, so I know it's quotient rule. Fine. Now we will solve the numerator. Differentiation of numerator, 2x minus 0. Differentiation of x square is 2x. Differentiation of 1 is 0. Second function as it is, minus differentiation of second function, first function as it is, whole divided by second function, that is denominator whole square. Open the bracket. 2x into x is 2x square minus x square minus of minus 1 becomes plus 1 whole divided by x square. Now what do we get? 2x square minus x square is just x square plus 1 divided by x square. So even in the options I have written it that way only, 1 plus 1 by x square. Remember that is okay. Now options, it is not wrong. Actually we can simplify this. Okay, so x square divided by x square plus 1 by x square cancels. We get 1 plus 1 by x square. 1 plus 1 by x square. Okay, so that is fine over here in options. 1 plus 1 by x square is the right answer. So only in the question that bracket was missing. If it was there, it would have been perfect. Okay, I hope it's clear. First step is quotient rule, and after that it is simplification. Moving on to the next question. The differential coefficient of x square plus 1 by x. Something similar, right? Previous one we had x square minus 1 by x, and I told you the bracket was missing. Here they made sure the bracket is there, so it's more like a typing mistake that was there in the previous question. X square plus 1 by x, again quotient rule, left hand side dy by dx, numerator let's differentiate. We have 2x plus 0, denominator as it is, minus denominator differentiation, numerator as it is, and denominator square, equal to, we have 2x into x, 2x square minus x square plus 1, oh sorry, minus 1, right? Yes, minus 1 whole divided by x square. 2x square minus x square, what do we get? We get x square minus 1 whole divided by x square. Again something very similar, so we have x square divided by x square, I'm splitting it 1 by x square. So we get 1 minus 1 by x square. Previous answer was 1 plus 1 by x square. This one is 1 minus 1 of 1 by x square. Option B is the right answer. We're solving more questions. I hope you all are getting comfortable. Question number 22. Y is equal to e to the power root 2x. E to the power root 2x. Now, so far chain rule I used to go one function inside another. Now this question we have one function which is inside another function which is inside another function. So two times chain rule is there. I'll go slow over here. See, first this highlighted part what you see, that is a function. Correct? So what we do is e to the power x. So dy by dx, differentiation of e to the power x, e to the power x only. But instead of x, we have root 2x. We have root 2x. So inside that, change the color, will go to yellow with little less thickness. Okay. So inside that there is one more function that I'm highlighting now. Okay, can you see that highlighted part? I need to increase the opacity. Okay, fine, that 2x that is there. Correct? Or what I'll do is I'll highlight it over here. That is better, I guess. Okay, this one inside part. So differentiation of root x is 1 by 2 root, instead of x we have again 2x. Correct? Now we need to differentiate again 2x. Differentiation of 2x is 2. Fine. So this 2 and this 2 cancels. What happens is e to the power root 2x whole divided by root 2x. We have that in option C answer. That's the right one. So we have used chain rule twice over here. Fine. Moving on. F of x is x square by e to the power x. F dash of 1. That means first we have to find f of x. F of x is given, we need to find f dash of x. After that, substitute x equal to 1. So dy by dx, or no, we'll put it as f dash of x only. Differentiation f dash of x is equal to differentiation of x square, numerator 2x, denominator as it is, minus differentiation of denominator e to the power x only, numerator as it is, whole divided by denominator whole square. Fine. I think we can simplify a little bit more. Differentiation on the left hand side, f dash of x. Now e to the power x is common. What is there outside is 2x minus x square. In fact, x also we could have brought outside. But that's fine, I guess, for now. Let's see. Whole divided by, we have e to the power x whole square is there. Correct? Okay, whole square. Now I can cancel off one of the e to the power x. E to the power x 1 cancels. Here out of 2, if I remove 1, 1 still remains. Fine. And now what we can do is just substitute the value. Which value? We should have f dash of x is there. Now it is f dash of 1. Substituting x equal to 1. Substituting x equal to 1. So we get 2 into 1 minus 1 square divided by e to the power 1. 2 to the power 1. 2 into 1 is 2. 2 minus 1 is 1 divided by e to the power 1 is e. Final answer 1 divided by e. So when substitution is there, we can actually reduce the simplification also. Fine. Even if you had not cancelled, that would have been still the same anyways. Okay, so that's all that we have in the first part of differentiation. Quite a few questions, 23 questions that we have solved. And before I give a check mark for the review, since this is a topic which most of you may not have studied before, let's quickly run through. Fine. I will go to the first page. What did we have? It's a study of change. We have dependent variable divided by dependent variable. We write dy by dx. Like how do we read it? Differentiation of y with respect to x. Fine. And then we had some standard rules. I'd rewritten those rules. What you have on the screen right now. We had x to the power n into x to the power n minus 1. Differentiation of x equal to 1. Differentiation of 1 by x is minus 1 by x square. Differentiation of root x, 1 by 2 root x. E to the power x is e to the power x. A to the power x is a to the power x log a to the base e. Then we have constant 0. Then we have log x is 1 by x. Fine. We can create many more also here, standard ones, by just solving them. Like for example, I can add one more over here, e to the power ax. By applying chain rule, what do we get? We get a can be considered a separate function, so differentiation of this will be e to the power ax. Now differentiating ax, you get into a. Fine. So in the material also you can find it. So they say directly differentiation of e to the power ax is a into e to the power ax. I'd not given it over here because I wouldn't be able to prove it that time that we can do it that way because chain rule was not taught. Okay, but you can remember this as well. E to the power ax is a into e to the power x. If you don't remember, no problem. You can still go for chain rule and get the answer. After this standard formula that we have, we came to the laws of differentiation. First one is constant. Keep the constant outside, differentiate function. Sum difference was simple. Product, differentiate first function, second function as it is, plus differentiate second function, first function as it is. Quotient rule, differentiate numerator, denominator as it is, then minus differentiate denominator, numerator as it is, divided by denominator square. Chain rule, function inside a function. So inside a function, we will assume that it is just x basically and differentiated. After differentiating the entire, what you highlight, what I used to usually highlight, I will differentiate again. And in the last, but one question or something where we had differentiation twice, I mean the chain rule twice inside only. So that is also possibilities. Constant, sum rule, product rule, and chain rule as well is done. Fine. So we have more of this, more rules to be followed. But for now, we are done with the first part of this particular unit, standard rules and laws. We'll move on to the next topic, implicit function. Now, what is this implicit function? The functions that we have been solving so far, we used to have y is equal to something. Correct? We had y is equal to, let's say, 2x plus 5. Correct? We had dependent variable, y is dependent on the values of x. Correct. But now what if I have to mix everything together? So this is not implicit function. This is what we have done so far. Now if at all I have x cube y square, okay, plus I will take xy. I'll then take only x and then take only y, okay, plus 2 equal to 0. Now this is an implicit function. Why? Can I solve for only x? Or can I solve for only y? No, it is not possible. It gets complicated. So we differentiate directly. Remember, x is a function, y is a function. Now if you have two functions together, which rule do we use? All that remains the same, our basic rules. So we have product function. What does product function say? Product of two functions, you differentiate first function, second function as it is, differentiate second function, first function as it is. So let's see what we get. We'll differentiate. I will write that also. Differentiate with respect to x, x cube, second function as it is. Then we have plus differentiation of second function first function as it is. What is the first function? X cube, right? Okay, first function as it is. So differentiation is complete. Plus, then again I have that x and y. So I need to differentiate first function, differentiation of x, y as it is, plus differentiation of y, and x as it is. X as it is. So I have finished that also. Then I have differentiation of x. I'll just highlight it. How much I have finished. Okay, first I did this. Okay, in yellow. I'll highlight in yellow over here. Differentiation. Okay. Then I will change the color to pink for this one. I have differentiated over here. Okay. Not yet differentiated. I just expanded for the time being. Next, I'll take the third one. A different color will take green. Okay, differentiation of x. What is the differentiation of x? Should I do it directly? No, or we'll just expand over here. Differentiation of x. Fine. Then we have differentiation of y. I'm continuing. Plus differentiation with respect to x for y. Plus differentiation of 2. Differentiation of 2. Right hand side differentiation of 0 is 0 only. So we don't have to bother. Now let me simplify further. Differentiation of x cube, it is in the form of x to the power n. Differentiation of x to the power n is n into x to the power n minus 1. So differentiation of x cube is 3 into x to the power 2. Correct? Y square as it is, not to be differentiated. Differentiation of y square. We know differentiation of y. Differentiation of y is dy by dx. See, we just had to write dy by dx. But instead of y, we have y square. So what will we do now? We'll take it as x. Now the chain rule has to be used. I'll highlight this. This y square chain rule has to be used. Now if it was x, what would we write? Differentiation of x square. Sorry, differentiation of x square would have been 2x. Correct? So differentiation of y square is 2y. Differentiation of y square is 2y. But did we really have differentiation of x only? No, we have differentiation of y square. So applying chain rule, now we need to differentiate y dy by dx. Differentiation of y is dy by dx. Why did I do that? Because instead of y, we had put x. Chain rule. Correct? Okay. Then x cube as it is. Plus differentiation of x with respect to x, which is equal to 1. If you actually see here, you get dx by dx. So it is equal to 1. Matches? Okay. Y as it is. Okay. Plus differentiation of y with respect to x dy by dx. And x as it is. That also I'll keep. Differentiation of x after that. Differentiation of x is 1. Differentiation of y is dy by dx. Differentiation of 2 is equal to 0. Correct? Now differentiation is complete. We have finished the differentiation. Now what should we do? Remember on the right hand side what do we have? Equal to 0. I'll write that also. Okay. Let me just highlight this. Okay. The right hand side when differentiation this is equal to 0. Now what I'll do is I'll keep all dy by dx on one side, remaining all I'll take to the other side. So I get 2y dy by dx into x cube. Then I have plus dy by dx into x plus dy by dx. All the ones with dy by dx I brought to left hand side. What is there on the right hand side? I have minus 3x square y square plus becomes minus when it goes to the other side. We have minus y. Okay, that's it. I believe. Okay, we have plus 1 also. Plus 1. So let me just highlight and show it to you the things that I've kept on one side from the previous one. Okay, so this was having dy by dx, this one was having dy by dx, this one not from one, from here I have dy by dx. These three I brought to one side, remaining I've all taken to the other side. In fact, it is not plus 1, it is minus 1. This is minus 1. So we have two sides. Now when we have common in the left hand side dy by dx, I'll take it outside the bracket. Dy by dx, inside the bracket what remains? 2x cube y. That's all that is remaining. Plus x is remaining. Plus nothing is remaining. So 1. equal to, on the other side we have minus common, I'll take it outside the bracket, and this is what we get. Since I'm putting minus outside the bracket, this becomes plus all of them. Correct. Now finally dy by dx, that's all that I wanted. No differentiation of y with respect to x. So we have minus sign 3x square y square plus y plus 1 all divided by 2x cube y plus x plus 1, and this is my final answer. So we will have to use product rule a lot of times when we have x and y mixed up together, and finally we are getting only dy by dx on the other side. Now let me rewrite this question, and I'll teach you a shortcut method because this definitely looks a little complicated. Correct? You'll be like, oh, but who will do so much for 1 mark? Now let me rewrite this question. X cube y square. We have x cube y square. Okay. And then what did we have? Xy. We have plus xy. I think then we had plus x plus y plus I think 1 or 2. Plus 2 we had, right? Okay. Equal to 0. This was the question. Now what is your shortcut rule? Shortcut rule is all that you need to do is write dy by dx on the left hand side. Whenever you have implicit function, write dy by dx on left hand side. Right hand side you write minus sign. Open the bracket. We will differentiate with respect to x, y is constant. For this rule, we are assuming y to be constant. So differentiation of y, 0. Differentiation of y square, 0. Differentiation of 2y, 0. Differentiation of e to the power y, all 0. Because y is 0. I mean y is constant. Differentiation of constant is 0. So it makes it easier. Then what we'll do is, we will differentiate in the denominator with respect to y. We'll keep x as constant. We'll differentiate with respect to y, keeping x as constant. Now let's follow this rule and see what we'll add. First we add x cube y square. I said y is constant. If y is constant, y cube is also constant. So we have constant into a function. It is no longer a product rule. Constant into a function is a constant rule way of differentiating. And what do? We keep the constant outside, differentiate function only. So for this problem, I'll write dy by dx left hand side. We have minus sign. We'll keep the bracket open. Okay. So y square is constant. Differentiation of x cube. Differentiation of x cube is 3x squared plus. Then we have xy. Here. I reached here. Okay. We have xy. Y is constant. So it is as good as having x into 2. What do? We keep it outside, no? So same way, xy, y we keep constant, outside differentiation of x is 1. Then we have plus x, differentiation of x is 1. Then we have plus y, differentiation of y is, now it is not dy by dx, 0. Differentiation of 2 is also 0. All divided by. Denominator, what we should do is, we are keeping x as constant. Y is the function and we are differentiating with respect to y. So differentiation of x with respect to x is 1. Differentiation of y with respect to y is 1. Differentiation of x square with respect to x is 2x. Differentiation of y square with respect to y is 2y. Okay, so we have x cube as it is. Differentiation of y square is 2y. No writing dy by dx because we are differentiating with respect to y. Okay, plus. Now again x is constant, no? X is constant. Differentiation of y is equal to 1 plus differentiation of x. Remember x is constant, 0. Differentiation of y with respect to y now, it is equal to 1. Differentiation of 2 equal to 0. Now finally, we'll just do a little bit of simplification. Left hand side we have dy by dx equal to minus sign outside. We'll simplify 3x square y square plus y plus 1. Done. All divided by 2x cube y plus x plus 1. And this is the answer. Now let's compare this answer with what we had got earlier. Left hand side, absolutely same. Right hand side, 3x square y square, 3x square y square. Then we had plus y plus 1. We had plus y plus 1. 2x cube y plus x plus 1. 2x cube y plus x plus 1. So we get exactly same answer. Much less efforts. But just that you need to remember this one formula. I will highlight that now. This particular formula. Differentiate with respect to x, keeping y as constant. Differentiate with respect to y, keeping x as constant. You use this, any problem with implicit function can be solved easily. Let me show a couple of more examples. Okay, now another one, I'll take something very similar. Okay, we'll take this example of 2x plus 3y plus x, in fact plus x plus y plus 9 equal to 0. I try to keep it little simple this time. X is there in this, y is there in this. Fine. Maybe you can still solve it for x and y separately, but don't, we'll try to use implicit function only. Fine. Okay. So we have dy by dx. What is the rule? Left hand side I have written dy by dx, minus sign outside. Now we have to differentiate with respect to x, keeping y as constant. Differentiation of 2x is 2 plus differentiation of 3y. Remember, y is constant. If y is constant into 3. If this is constant into 3, what will happen? That is also a constant. Differentiation of constant is 0 plus differentiation of x is 1. Differentiation of y is 0. Differentiation of 9 is also 0. This is all that you get. All divided by 2x. Differentiation of 2x, now this time with respect to y, keeping x as constant. So this becomes 0 plus differentiation of 3y. 3 is constant, keep it outside. Differentiation of y is 1 plus differentiation of x, x is a constant, 0. Only in this formula x is a constant. Okay, differentiation of y is equal to 1 plus differentiation of 9 is 0. So you get a very simple answer over here. Minus is outside, 2 plus 1 is 3, divided by 3 plus 1 is 4. So we get minus 3 by 4 as the final answer. Okay, we'll take one more question now. We'll go with log now. Okay, we will take log x y. Differentiation of log xy, we will have to find out now, log xy. Then we'll continue plus let's put it as x square y, okay, equal to 0. First step is always we have everything on one side. Fine. Now how to solve this? First we have log xy. Do we know the differentiation of log xy? We do not. Okay. Now we will go to our shortcut method, dy by dx. Left hand side I have written. Right hand side, what should I do? I should put minus sign, put small bracket open. Now differentiation of log xy. Remember, I told you first in the numerator y is constant. Now what if it was log x into 2, what would we do? We would apply chain rule, right? We would take that as x and then multiply and do all of that. So same way we will assume y to be constant. So we will take differentiation of log xy first. Differentiation of log x is 1 by x. So differentiation of log xy is 1 by xy. After that we would apply chain rule, no, for this part. We would apply chain rule for this. Differentiation of xy is how much? Remember, y is constant. Differentiation of x is 1. Y is constant. Differentiation of x is 1. With this chain rule is complete. Correct. Plus differentiation of x square. Differentiation of x square. Y is constant over here. Differentiation of x square is 2x. Done. Bracket close. Now same thing. Entire thing again we'll have to differentiate with respect to y. The differentiation of xy, this time x is constant. So we again get 1 by xy into This time x is constant as it is. Differentiation of y is 1 plus y is constant. Differentiation of, in fact, x is constant. Differentiation of y is equal to 1. That's it. If you want, we can simplify this. One of the y gets cancelled. So we get dy by dx equal to minus sign outside. We have one y cancelling over here. Fine. And then that's it, right? Yes. 1 by x plus we have 2xy all divided by 1x gets cancelled over here. 1 by y plus x square. This is my final answer. So this is the rule for implicit function. So whenever we have x and y mixed together, just remember this one rule. Left hand side will write dy by dx. Right hand side minus and outside differentiate with respect to x, keeping y as constant. So y can be thought as like any other number, 1, 2, 3, 4, 5. How would you differentiate? That way. Like xy becomes x into 2, 2x. How would you differentiate? 2 you would keep it aside, differentiate on the x. Correct? Same way. Everything you follow it that way, you'll get the answer. We'll take few more questions. Okay. We'll see how much we have actually understood. Okay. We'll continue with the numbering. Fine. Question number 24. Given e to the power minus xy minus 4xy is equal to 0. Okay. So x is there, y is there, both mixed up. Correct? Okay. So we'll use shortcut method. What is my shortcut method? Say dy by dx on the left hand side, right hand side equal to minus sign outside, bracket open, differentiation of e to the power minus xy. It is as good as e to the power minus x. Y will take it as 2, 2x. So what is the differentiation of e to the power minus 2x? Minus 2x e to the power minus 2x. Correct? Okay, so it's chain rule now. E to the power minus xy. Now we need to differentiate minus xy. So minus y, I'll keep the constant outside. Differentiation of x is equal to 1. Fine. Minus y is constant, 4 is constant. So 4y is outside. Differentiation of x is equal to 1. Fine. All divided by, now I need to differentiate with respect to y. Differentiation with respect to y, x is constant. So again e to the power minus xy, differentiation of e to the power minus xy is e to the power minus xy into, now applying chain rule, we have to take differentiation of this value, right? Same thing what we did in the numerator. So this time minus x is constant, differentiation of y is equal to 1 minus 4x is constant, differentiation of y is equal to 1. Clear? Do we have that option? We might have to simplify further. Equal to, okay, minus sign is there, e to the power minus xy is there, minus y will get it outside. Okay, minus y is there, e to the power minus xy is there. Okay, minus 4y. Okay, just remove the ones, and here we have minus x e to the power minus xy, and we have minus 4x. But in the options, if you see, it is nowhere close. Now we need to simplify it further. As I see in the numerator, we have y common. We'll take it outside the bracket. And in the denominator, we have x common. We'll take it outside the bracket. Okay. In the numerator, shall we take even minus sign outside? Okay, we'll take minus sign outside, so it becomes plus. Okay, plus it becomes. So we have y outside, minus is already taken, so we have e to the power minus xy. Fine, and we have plus sign over here. Y is taken, 4 remains inside. All divided by. Oh, we might have to take minus sign here also outside, so we have minus x outside, and we have e to the power minus xy plus 4 inside. Cancels, what remains is y by x, minus sign is there, so minus y by x, minus y by x there in option A. If you solve it in the regular method, it goes little lengthier. This much is enough for us. Remember the rule of doing it in shortcut method.
Moving on to the next question, we have x square by a square minus y square by a square equal to 1. We'll make it as a simple equation first. Okay, we have x square by a square. I'm just writing it as it is, minus y square by a square equal to 1. A square is common, so I will take the common denominator a square. So we got x square minus y square equal to 1. Cross multiply, we get x square minus y square equal to a square. So this is the equation that we have right now. Now either we can get everything to one side or we can even leave it, because a square, a is a constant anyways. Differentiation of constant will be 0. Okay. But no, we will get everything on one side. We'll follow the rules strictly. Fine, minus a square equal to 0. This should be the way in which I am gonna use before using shortcut method. This should be the form in which the variable should be. Fine, everything on one side, other side is 0. Now differentiation on the left hand side, we write dy by dx equal to minus sign outside. Differentiation of x square, 2x. Differentiation of y square, remember it's a 0. It's constant, divided by x square. Differentiation of x square with respect to y, x is constant, 0, minus differentiation of y square to y, again we have 0. So this is how fast you can actually solve when we use the shortcut method. So what cancels? Minus 2 cancels, we get x divided by y, which is there in the answer. Simple, right? So if you see the differentiation part, it's quite simple. We took more time actually to simplify the given equation. Moving on to the next question, we have log x divided by y equal to x plus y. X and y are there, both mixed up, so we'll get everything to one side. That is the first step. So we get log x by y minus x minus y equal to 0. Next step, dy by dx on the left hand side equal to minus sign differentiation of log something. Differentiation of log something is, remember, y is constant over here, so it is not function by function now. Okay, differentiation of log something is 1 by something. Differentiation of log x is 1 by x. Okay, so as it is, but then we have to apply chain rule. Y by x, sorry, x by y, it is differentiation of x by y. Remember, y is constant, so I'll take 1 by y outside, which is constant. Differentiation of x is 1, I'll write into 1, minus differentiation of x. Differentiation of x is 1. Differentiation of y is 0. Bracket close. All divided by differentiation of, again we have log x, 1 by x into what is constant now? X is constant. Differentiation of 1 by y is remaining. Differentiation of 1 by y is minus 1 by y square. How did I get this? Differentiation of 1 by x with respect to x is minus 1 by x square. Differentiation of 1 by y with respect to y is minus 1 by y square. Okay, fine. Minus differentiation of x. Remember, it's with respect to y and x is constant, so 0. Differentiation of y is 1. Done. Differentiation is done. Definitely answer is not there, so it's fine. We will have to simplify further. Okay, we have minus sign outside. We have y by x into 1 by y. After that, what matters? Minus 1 is there. Okay, divided by y by x into minus x by y square minus 1. This is all that remains after simplifying. Now we have y cancelling, we have y cancelling with one of the y's, x cancelling with x, but remember minus sign is still there. Minus left hand side as it is, dy by dx. Okay, minus sign outside, so we are left with this much only, what I am writing now, that is 1 by x minus 1 divided by, minus is still remaining, right? Okay, minus 1 by y minus 1. Fine. So what we can do is, you can take that minus sign outside, we can make this as plus, we'll make this as plus, we'll take minus sign outside. Why? So that we can cancel this off.
Fine. So what remains now? 1 by x minus 1. Take LCM. X 1 minus x. Whole divided by. Take LCM. Y 1 plus y. Correct. Simplifying further. Okay. So we get y into 1 minus x and x into 1 plus y. Do we have this option? Y into 1 minus x is there in option A. Just make sure it is matching. Yes, it is matching absolutely to the last value. So if you see, actually differentiation was just one step. After that it is simplification. Differentiation, do it little slowly. After that, simplify quickly. Fine, we'll move on to the next question. Question number 27. Okay, it's comparatively an easier question. Looks like something which we solved in our examples. So I'll rewrite that. X cube plus y cube minus 3axy equal to 0. So good for us, it is already in the standard form. What is my rule? Dy by dx on the left hand side equal to minus sign outside, differentiation with respect to x, differentiation of x cube 3x square, differentiation of y cube 0, and we have constant 3ay is constant, differentiation of x that is remaining is 1, all divided by, now differentiate with respect to y. Okay, so differentiation of x cube is 0 plus y cube is 3y square minus 3ax is constant, differentiation of y is equal to 1. Just rewrite everything by eliminating zeros now. Minus, and I think I can get 3 outside. Okay, and then what remains is x square minus 3ay, or 3 is taken outside. So we have ay remaining. Correct? Okay. Divided by 3 will take outside. And we have y square minus ax. 3 definitely cancels, but do we have to take minus sign inside? Yes, we may have to, but check where we'll have to take it inside. Fine. Looks like numerator will have to take it inside. So we'll take ay minus x square divided by y square minus ax. Just taking minus sign up inside such that the answers come closest. That we'll have to see the options and do it. Okay, so we get this as the answer. Option B is the right answer. We'll move on to the next question now. If you think I'm going a little fast, please pause the video till you understand what exactly is done. I'm repeating again, differentiation. You just remember the rule for implicit function. I hope you are comfortable with the basic differentiation. After that, this rule, if you remember, any problem you can solve. Minus sign outside, differentiate with respect to x, keeping y as constant. Then differentiate with respect to y, keeping x as constant. That's it. Moving on to the next question, question number 28. Good for us, it is given in the standard form, also something similar to what we solved in the examples. So when you have implicit function, you get such questions like this most of the time. Okay, so we'll rewrite that. As per our rule, everything should come on one side. On the other side, we write equal to 0. Next step, dy by dx equal to minus sign outside, differentiate with respect to x, differentiation of y square will be 0, plus 2 and g are constant, differentiation of x is 1. 2, h and g, all three are constant. Constant into constant into constant is a constant. Differentiation of constant is 0, all divided by x square. Now we are differentiating with respect to y. Remember, x square 0 plus 2y. Differentiation of y square is 2y plus 2g and x. All three are constant. Differentiation of constant is 0 plus 2h is constant. Differentiation of y is 1. Differentiation is complete. Now I'll read the question. I'll continue reading the question. See, after we had done this much, we had not read it that time. They have asked for dy by dx at x equal to 0, y equal to 0. 0, 0 means x equal to 0, x equal to 0, y equal to 0. Let me substitute. Now substituting x equal to 0, y equal to 0. Let's see what we get, because I don't need to simplify it simply, because anyways I'm simplifying further by putting x equal to 0, y equal to 0, minus 2 into 0 plus 2 into g. That's all that is remaining. All divided by 2 into 0 plus 2 into h. What remains? Minus 2g divided by 2h. 2 2 cancels, minus g by h. Minus g by h is there in the option. So this is next level now after we do the differentiation where we substitute the values. Fine. We have another question like this, another simple question. The last one that I am solving under implicit function. X cube minus 2x square y square plus 5x plus y minus 5 equal to 0. At x equal to 1, y equal to 1. That means I have to differentiate first and after that substitute x equal to 1, y equal to 1. Let me write the given question. I'm following steps. Everything on one side, other side I should have 0. Then I write dy by dx equal to minus sign outside. Differentiation of x cube is 3x square minus 2y square. This much is constant. Correct? So here if you see 2 is constant, minus is constant, xy square is constant. This much is constant. I've kept it outside. Differentiation of x square 2x. Correct? Okay. Plus differentiation of 5x. Differentiation of 5x is 5. Differentiation of y 0. Differentiation of 5 0. All divided by. Now we have to differentiate with respect to y, keeping x as constant. Okay, so x cube, differentiation of x cube will be 0 minus, this time what is constant? 2 is constant, x square is also constant in the denominator. Differentiation of y square is 2y plus differentiation of 5x 0, differentiation of y 1, differentiation of minus 5 0. Done. And when we have to substitute values, there is no point of simplification. So now substituting, like we did in the previous problem, substituting x equal to 1, y equal to 1. It's given over here. Okay. What do we get? Minus 3 into 1 square minus 2 into 1 square 2 into 1 plus 5 divided by minus 2 into 1 square 2 into 1 plus 1. Let me simplify. 3 into 1 is 3. 3 minus 4, right? 3 minus 2, 2s are 4. 3 minus 4 is minus 1 and plus 5. Minus 1 plus 5 is plus 4. So minus 4 is all that remains denominator. We have 2 into 2, 4, right? We have minus 4 plus 1 minus 3. Minus 4 plus 1 we have minus 3. Minus and minus cancels. 4 by 3 is the final answer. 4 by 3 given in the question. I mean in the options. Option A is the right answer. So this is what we learned in implicit function. Follow a simple rule. Get everything on one side. When do we use it? When x and y are mixed up, you cannot solve for one of them. After that, we write dy by dx on left hand side. Right hand side is minus. Differentiate with respect to x, keeping y as constant. All divided by differentiate with respect to y, keeping x as constant. And then we had last two problems where you have to simplify values, and that should not be difficult. That's it in implicit function. So we have already finished standard rules and laws, and now we have already finished implicit function. Two more parts to go. Parametric, logarithmic. Let's see what parametric function is. So far, we had two variables. We had x, we had y. And y's values are dependent on the values of x. Even in implicit function for that matter, though it was mixed up, like x and y was together and all of that, ultimately we were calculating dy by dx. That means differentiation of y with respect to x. That means what is the rate of change in y with the small change in x. Now comes the third variable. Now what if both the variables that we have taken so far, that is x and y, are expressed using a third variable? Let me give you an example. Let's say x is equal to, let me adjust this size. Okay, x is equal to
we will take 2t, small one, x is equal to 2t, x is expressed using third variable. I will also write y is equal to, this is directly a question, okay, y is equal to, let me write 3t cube, 3t cube, fine. Now if I have to differentiate the first equation, see when we have to differentiate y with respect to x, what did we write? Dy by dx. So if I have to differentiate x, now it's with respect to x values are dependent on the values of t. So it becomes dx by dt, differentiation of x with respect to t. I'll repeat again, when we were differentiating y with respect to x, we used to write dy by dx. So differentiating x with respect to t becomes dx by dt equal to, we are differentiating with respect to t. So differentiation of 2t, 2 is constant, differentiation of t will be equal to 1. Same as differentiation of x with respect to x is 1, differentiation of t with respect to t is also equal to 1. This answer is equal to 2. Next, if you differentiate the next equation, y is equal to 3t square. Y's values are dependent on the values of t. So this becomes dy by dt, differentiation of y with respect to t, equal to, we have 3 constant outside, differentiation of t cube, 3t square. 3t square. And what is the final answer? 9t square. So we got differentiation of x with respect to t, dx by dt equal to 2. Differentiation of y with respect to t, we got 9t square. But this is not what we wanted. We had to calculate dy by dx. I want dy, I'll highlight now, see this part. I want dy and dx is there over here, dx. Both are there in the numerator. Correct. What should we do? Now if I number this just to identify purpose, just for the purpose of identifying, I'll call this as 1, I'll call this as 2. What do I need to do? I need to do 2 divided by 1. See what I get if I do 2 divided by 1. I get dy by dt, this is 2, whole divided by dx by dt. In the entire maths portion that I've covered so far, multiple times I told you, whatever you do on one side of the equation, do the same thing on the other side of the equation. So we have 9t square all divided by 2. Okay, so we will cancel out dt and dt. We get dy by dx equal to 9t square by 2. Fine. Simple, right? So when we have these parametric equations where one variable, in fact, each variable is expressed using the third variable, questions will be simpler. But just that we need to do dy by dt separately, dx by dt separately, and then always do dy by dt divided by dx by dt. One more example I'll take. Okay. So we will take x to be equal to log. Let's take 2t. I'm using a little bit of chain function also, okay? And then I'll take y is equal to e to the power, let's here also use chain function, e to the power, let me take log t, e to the power log t. Fine, I've used chain function in both of them. So what will I do first? I will write dx by dt, differentiation of x with respect to t, equal to log, it is as good as log x. Differentiation of log x is 1 by x. Differentiation of log t is 1 by t. But instead of t, we have 2t. So it becomes 1 by 2t. After that, into, we are using chain rule. Differentiation of 2t is 2. 2 cancels, I get 1 by t. Done. First part is done. Now y, dy by dt. Differentiation of y with respect to t. Now it is in the form of e to the power t. Correct, but instead of t we have log t. So e to the power t is e to the power t only. Now I have to apply chain rule, differentiation of log t with respect to t, 1 by t. So I got dx by dt, I got dy by dt, final answer dy by dt by dx by dt, which I may not write in the next question. I'll do it directly, okay? It's always dy by dt divided by dx by dt equal to, we have e to the power log t all divided by t,
and this again all divided by 1 by t. We can simplify it. Okay, we'll not get into the simplification for now. Okay, as we solve questions, we'll simplify the questions and get the final answer just to match the options. Should be enough. We have few questions which are there. Okay, we'll go to those questions. Numbering continues. We have reached question number 30 now. See the question. They have given us x is equal to at square. A is a constant. So it is as good as the example that I have taken, like 2t. At square. Y is equal to 2at. What should I do first? Dx by dt equal to. A is a constant. Differentiation of t square is 2t. Then I have dy by dt equal to 2a is constant. Differentiation of t is equal to 1. Now I have to merge both of them. I get dy by dt. Let me write that in this problem. Again, the next one I'm not writing this. Divided by dx by dt. So I get 2a divided by 2at. A cancels, 2 cancels. Final answer is 1 by t. 1 by t. Do we have that option? Yes, we do. Option C is the right answer. Easy, right? Few more questions. Question number 31. Question is x is equal to 2t plus 5, y is equal to t square minus 2. So let's differentiate x with respect to t equal to differentiation of 2t is 2. Differentiation of 5, 0. How is differentiation of 2t equal to 2? 2 is the constant. Differentiation of t is equal to 1. If you want, I'll write that also. Okay. Final answer is just 2. Now I'll take differentiation of y with respect to t. Okay. Differentiation of t square is 2t, and again differentiation of minus 2 is 0. Khatam. What's the final answer now? Dy by dx is equal to 2t divided by 2. I've just merged both of them now. 2 cancels. What remains is t. Okay. We'll go to the next question. Question number 32. X is given, y is given. Directly we'll solve it now. Okay. Dx by dt equal to differentiation of 3t square. 3 is constant. Differentiation of t square is 2 into t. Differentiation of minus 1, 0. 3 2s are 6. Final answer is 60. And dy by dt, differentiation of y with respect to t. T cube minus t is given. Differentiation of t cube is 3t square. Differentiation of t is 1. So we have dy by dt, we have dx by dt. Now I'll join both of them. Dy by dx is equal to 3t square minus 1 divided by 60. Do we have that? Yes, we do. Option C is the right answer. Moving on to the next question, question number 33. Dx by dt, without reading the question, I'm doing this now, equal to a is constant. Differentiation of t square is 2t. Dy by dt, 2a is constant. Differentiation of t is 1. So just to simplify this, we get 2at over here and we get 2a over here. Now we go one step further. If you remember, we had some questions where we had to substitute the value of x and y. Correct? So first we differentiated and then substituted the value. Here if you see in this question, they have asked for the value of dy by dx at t equal to 2. Okay, we have not got dy by dx yet. So let me combine dy by dx equal to 2a, that is dy by dt, divided by 2at, that is dx by dt. Cancelling, we get 1 by t. This is dy by dx. But they said dy by dx at t equal to 2. Dy by dx at t equal to 2. Substitute 2 in place of t. Khatam. Answer is A. Easy, right? Okay, this looks easy now. Moving on to the next question. 34. X is given, y is given. And if you see, we have function divided by function. Two functions are there both for x as well as y. So this is going to be little lengthy. So what is the rule when we have function divided by function? We differentiate first function, that is numerator. Second function we leave as it is, minus differentiate second function
First function we leave as it is, all divided by second function square. So we'll do that. We get dx by dt equal to differentiation of 1, 0, differentiation of t square minus 2t, second function as it is, okay, minus differentiation of second function, we have 0 plus 2t, first function as it is, okay, all divided by second function square. Done. This is my dx by dt. I am not going to simplify it now because my question's requirement is dy by dx at t equal to 1. So anyways, I have to substitute the value. There is no point simplifying it. Next, I write dy by dt. Here also we have two functions. Now this time I'll use blue, first function, second function. Okay. And now let me solve this. Okay. Differentiation of 2t is 2. Second function as it is minus differentiation of second function 0 plus 2t, first function as it is, all divided by second function square. Fine. So we have dx by dt, we have dy by dt. Next we need dy by dx, dy by dx. That means I have to divide. If I have to identify these functions, this is function number 1. Function number 2, that is differentiation of the first function, differentiation of the second function, both done. Now we need 2 divided by 1. And if you see the denominator is same, it cancels off. So the numerators are remaining, but make sure you write second one first, which is dy by dt by dx by dt. Okay, so equal to 2 into 1 plus t square minus 2t into 2t, all divided by, now dx by dt ka numerator minus 2t 1 plus t square minus 2t into 1 minus t square. This is dy by dx. Last step, dy by dx at t equal to 1. Substituting the value of t equal to 1, 2. 1 plus 1 square is 1 minus 2 into 1, 2 into 1. All divided by minus 2 into 1, 1 plus 1. Then we have minus 2 into 1, 1 minus 1. Numerator now 2 into 2, we have 4 minus 2 into 2, again we have 4. We have 4 minus 4, which is 0. Remember now 0 divided by anything is 0. But if it is 0 by 0, then it is not defined. So I still need to solve the denominator divided by minus 2 into 2 is minus 4 and minus 2 into 0 is 0. So minus 4 we get 0 divided by minus 4. Final answer is 0, which is there in option C. So here we have to use quotient rule, but all the other functions, all the other rules remained same. And since we have solved enough questions using the basic rule and formulae, this shouldn't be difficult. It is just that instead of x, we have t. We are differentiating with respect to t. One more question before we end this parametric equations. Requirement, jump to the requirement, we have to substitute t equal to 2. So we'll differentiate now. Differentiation of x with respect to t. Differentiation of t, 1. Differentiation of t to the power minus 1. Remember, t to the power minus 1 is same as 1 by t. Differentiation of 1 by t minus 1 by t square. Differentiation of 1 by x is minus 1 by x square. Differentiation of 1 by t is minus 1 by t square. Done. Next we have dy by dt. Differentiation of t, we have 1 minus differentiation of t to the power minus 1. I just told you minus 1 by t square. So minus into minus becomes plus. So we got the values dy by dt. We got the value d by x by dt. Now we'll divide. We get dy by dx first. We have 1 plus 1 by t square all divided by 1 minus 1 by t square.
Do you want to substitute the value here only instead of simplifying? No need of LCM and all. We'll substitute here only. Okay. Now we have dy by dx at t equal to 2, 1 plus 1 by t square is there, no? So we'll write 2 square whole divided by 1 minus 1 by 2 square. Correct. So we get 1 plus 1 by 4 divided by 1 minus 1 by 4. Can use LCM, but see, otherwise also we know this, right? 1 plus 1 fourth. How much is this? 5 by 4. 4 plus 1, that is the LCM, okay, equal to 1 minus 1 by 4. 4 minus 1 is 3 by 4. 4 4 cancels. 5 by 3 is the final answer. We have that in option C. So from there it is just a simplification, makes it easier because we have numbers to be substituted. So that's it. That's all that is there in parametric equations. So if you actually see in differentiation, once you understand the basic rules, especially the chain rule of how to apply, then implicit also I gave you just one change. Then in parametric, I told you we need to do it separately and then divide them. We get the answer. So we finished the standard rules, we finished implicit function, we finished parametric functions. Last one that we have is logarithmic differentiation. We'll finish that in the next 10 to 15 minutes. Will not take much more than that. Logarithmic differentiation. Now, when do we use this form of differentiation? Two cases. Case 1, we have f of x, that is one function. We have g of x, another function, and another function, and so on. You can have more than this also. See, if you have two functions, we know how to differentiate. We can use product rule. Differentiation of first function into second as it is, plus differentiation of second function into first as it is. This we know. We have solved so many questions on this. But what if you have more than two functions? Then we use logarithmic differentiation. How to solve? We'll see little later. Second case, we have function raised to the power function f of x raised to the power g of x. How does it work? Now see, when we have three functions, let me take one example. I will take y is equal to, we'll keep it simple, x, one function, into log x. This is also fine. So far we have done. And we'll take another function e to the power x. So we have e to the power x into log x. So whatever is simplified, we cannot make it less than that. Now, if I have to use product rule, then first 2 I have to consider as one function and all of that can be done, but it gets very complicated. So what we do over here is, we take log on both sides. We get, taking log both sides, what do we get? We get log y. Correct? Equal to, we get log of e to the power x into log x. I'll just put this bracket. Now in log chapter I have told you, if you recall, logarithm of mn is equal to log m plus log n. Correct? So I can expand this. So let me expand this. Now see, differentiation I have not yet started. It is just logarithm for the time being. We have log y equal to log e to the power x plus log x plus log of log x. Now this we know to differentiate very well. Everywhere we have to use chain rule and simplify. Now differentiating both these sides. Differentiation of log y. Differentiation of log y with respect to x. It is 1 by y. Correct? Because differentiation of log x with respect to x is 1 by x. So we get 1 by y. But we are using chain rule. So we get dy by dx. Correct? That's how chain rule works. Because instead of y we add x. So we have to differentiate y separately. Further, right hand side equal to. Again chain rule, we have log e to the power x. Differentiation of e to the power x is 1 by e to the power x. Differentiation of log e to the power x is 1 by
e to the power x. We have considered it as a separate function. So now differentiate e to the power x. We'll write that as e to the power x only. Further, here we have log x. Differentiation of log x is 1 by x. Further, we have log x. Differentiation of log x is 1 by x. So differentiation of log x is 1 by log x. Now we have to use chain rule. Now differentiation of log x is 1 by x. We want only dy by dx. So we get dy by dx equal to, take y to the other side. So y into 1 by e to the power x, and e to the power x cancels. So we just get 1. Okay. Plus 1 by x, and then we get plus 1 by x log x. Fine. Further, we can simplify this. In place of y, we can write the given question, that is this value. We can do this. Okay. Fine. Then depending on the options and in the question, we will solve this. This is one way. This is one category of questions where we will have to use logarithm. See, logarithm differentiation is nothing but we take log on both sides and then differentiate. Nothing changes. Differentiation, everything is same. Like I could have even used implicit rule over here, getting everything on one side. But then there was only one y, that is log y. So I decided not to. So I differentiated it in normal method. Second case is when we have function raised to the power function. Let me give an example for that also. Let's say we have y is equal to x to the power y. Now if it is x to the power n, I know n into x to the power n minus 1. Or if I have a to the power x, I know it is a to the power x log a. That is, if I have function to the power constant, I know. Constant to the power function, I know. But here I have function to the power function. X is a function, y is a function. And there is no standard rule for this. So what do? Take log on both sides. So I get log y equal to log of x to the power y. So why did we do this? Because in logarithm, again going back to that first chapter, 4th unit, logarithm of m to the power n is equal to n log m. Simplifying now, we have log y as it is equal to, we will have y log x. Now we will have to differentiate this. Now let us use implicit rule also, so that we get a small little bit of revision over there. So I get everything on one side. The rule for implicit function is log y minus y log x equal to 0. Get everything on one side. After that, what should we do? We should write dy by dx on the left hand side equal to right hand side minus sign outside. Differentiate with respect to x, keeping y as constant. That means we are assuming y is constant. If y is constant, log y is also constant. Differentiation of constant 0 minus y is constant. I'll keep y as it is. Differentiation of log x is 1 by x, all divided by. Now denominator, what should we do? Differentiate with respect to y, keeping x as constant. So differentiation of log y will be 1 by y. Don't write dy by dx. We are using implicit rule. Differentiate y with respect to y. Fine. Minus log x is constant. This time log x is not a function because x is not a function. Correct? Into differentiation of y will be equal to 1. If I still have to simplify, minus and minus sign gets cancelled, which is there inside the bracket. So we get y by x all divided by, let's take LCM here. We have y, we get 1 minus y log x. Correct? Simplifying further. Now you know we have to take reciprocal. We get y square divided by x into 1 minus y log x. This is the final answer. So this is the second category type of questions where we use logarithmic differentiation, basically just putting log on both sides, simplifying it first and then differentiating. So that's it. That's all that is there. Only two questions I've solved from logarithmic differentiation because it is not that important. Okay, I've taught the concept because this particular concept is there in the syllabus. But again, when the questions are asked, it is usually not asked because, as you can see, it's quite lengthy and it is a little difficult to ask for just 1 mark. But these two, just know how to solve. In logarithmic differentiation, we just have to take log on both sides and then differentiate normally. With that, we have completed all the 4 parts that we had in differentiation. We started with standard rules, we then went to implicit function, parametric function, and finally logarithmic differentiation. We still have some questions on differentiation where we apply the concept of differentiation in day-to-day life. But then it's a separate video, okay, that will be taken up after integration because the questions are mixed over there. How we use concepts of differentiation and integration in day-to-day life as well. That's it. That's all that we have in differentiation. Thank you so much for watching.